Hello everyone, how are you all doing today? Hello Kyrie Aravan, hello Katten, hello Cinemax. Wonderful to see y'all. Tonight is gonna be more Rust. I am so excited to keep going. Before I get over to it, I've got a couple things I'm gonna bring up just as usual. My live 2D might be done by this weekend. We'll see. I am so fucking excited. Oh, it's looking so good, y'all. Ooh. KK all the way. Thank you very much for the follow. Welcome to Uplink City. Oh, fellow Automatuber. Hello. Yeah. Couple things to note. I am so excited for the new model. It's gonna look amazing. It's just looking so good so far. Other things, there was something else, right? Pokemon Legends, yes. God, I wish I had my copy already, but I got the physical copy from Pokemon Center because I want that Arceus plushie, so I don't have it yet, and even when I do get it, I'm probably not going to be able to stream it just because I don't really, one, I don't actually have a capture card at the moment, and two, I've got a couple just issues with my Switch at the moment. The fan is giving out, and I don't want to, push it further because that'd be risky, but yeah. Anyway, tonight's gonna be more Rust. I'm finally getting onto the section of the book where we're gonna fan give out. The fan for my Nintendo Switch is starting to fail. It's buzzing a lot, not able to it's not actually pushing much air. But yeah. Hopefully, hopefully I will be able to get a new one soon. Yeah, I'd really like to get a capture card at some point. That would be really nice, yeah. I was afraid it was your PC. No, my PC is doing just fine right now. Yeah, I can get the PC sorted if needed, but, Switch is a lot harder to repair. Yeah, I cannot wait for Legends. I am so excited for it. All my friends who have it have been saying really positive things about it. I'm just hyped. It looks really good, really exciting. The concept of a Monster Hunter Pokemon game is really interesting to me, and I'm just really interested in what it's indicating for the future of Pokemon as a franchise. Hello, Non! Wonderful to see you. Yeah. How about we get over to the book? Let me, because Edge and Viscode suck. Fuck is the Viscode? There. And also, I'll have music in a second. Traits, and, waiting on my copy of Legends to arrive on Monday. Same. God, I cannot wait for, the sitting Arceus plushie. Oh, it's gonna be so good. It's gonna be so good. Yeah. It's time for Rust. Last time, I got through, collections, error handling, and the first part of generics, or the first part of generics, traits, and lifetimes, so tonight we're gonna do traits, lifetimes, tests, and hopefully beyond. I appreciate the desks, Max. Yep, it is as usual for Friday night and Adderall night, so I'm gonna be hyped up on that. We're gonna have a good time. Why is my audio so loud? There, better. Okay. A trait tells the Rust compiler about functionality a particular type has and can share with other types. We can use traits to define shared behavior in an abstract way, and we can use trait bounds to specify that a generic type can be any type that has certain behavior. Traits are similar to a feature often called interfaces in other languages, although with some differences. Are you making a game? I've got a few games, game projects on the docket. I've got Soul and Silicon, a queer and trans dating simulator for the Game Boy Color. I've got Project Uplink, which is like still very much in planning stages. And I've got Project Deicide, a project being led by a very good friend of mine, Alicia, which is gonna be MMO raid content without the rest of the MMO, provided I can actually write it. But yeah, I'm not sure quite what I want to do with Rust yet, but I do want to learn it anyway, because probably pretty important. But yeah, I like learning new languages and how languages and computers work. Yeah, without further ado, traits are often similar to a feature often called interfaces in other languages, although with some differences. Type's behavior consists of the methods we can call on that type. Different types share the same behavior if we can call the same methods on all of those types. Trait defs are a great way to group method signatures together to define a set of behaviors necessary to accomplish some purpose. For example, let's say we have multiple structs that hold various kinds and amounts of text, news article that holds a story filled in a particular location, and a tweet that can have at most 280 characters along with metadata that indicates whether it was a new tweet, a retweet, or a reply to another tweet. Yeah. Oh, hello, Sunroses! Good to see ya! It's Rust Night. I'm very excited. Stretchy! Thank you, gosh, cute. Oh, thank you. I want to make a media aggregator library named Aggregator that can display summaries of data that might be stored in a news article or tweet instance. To do this, we need a summary from each type, and we'll request that summary by calling a summarize method on an instance. Listing 1012 shows the definition of a public summary trait that expresses this behavior. So I'm gonna quickly, yeah. Delete. Don't ask me again. I know what I'm doing, okay? Alright. In librs, we are gonna have pub trait summary, then summarize, and self string semicolon, because we don't have to fill it out, we're just defining it. Okay. Here to declare a trait using the trait keyword and the trait's name, which is summary. Also declare the trait as pub, so that crates depending on this trait can make use of this trait too, as we'll see in a few examples. Inside the curly brackets, we declare the method signatures that describe the behaviors of the types that implement this trait, which in this case is a fun summarize and self to string. After the method signature, instead of providing an implementation within curly brackets, just drop a semicolon. Must provide own custom behavior for the body of the method. Compiler will enforce that any type that has the summary trait will have the method summarized defined with this signature exactly. A trait can have multiple methods. Method signatures are listed one per line, and each line ends in a semicolon. Now, so we've got this, we can, start implementing. Now that we've defined the desired signatures of the summary traits methods, we can implement it on the types in our media aggregator. So we have a pub, struct, news, article, pub, headline, string, pub, location, string, pub, author, string, string, pub, content, semicolon, God. Right, then, impl, summary for news article. Ooh, that's a nice syntax for implementing, okay. And summarize, and that autofill is okay. Then they're using a format, dumb by dumb friend, dumb bump, with self headline, self author, then self location, Then that's a return. Yeah. Well, the sparkly typing, yeah, that is an effect I've got in VS. That is one of the extensions I've got for VS Code. Let me pull it up. What was it called? Where is it? Power mode. Power mode's a cool one. Yeah, basically just does fancy GIF particle effects and such. It's got like a effect that shakes the text around, but I don't like it, so I didn't do it. Yeah, Cupid seems like it'd be mega distracting. Very valid, yeah. Alright. Yeah, Substruct tweet. Shaky hands. Pub username string. Pub content string. Pub reply pool. Pub pool. Impulse summary for tweet. Then summarize. And self. Turn format colon self username self content. Alright. I'm playing Minecraft. When you're typing a comment, your icon vibrates around like it's talking, which is cute and funny, but also makes it hard to focus on what we're typing. Yeah. Okay, so now we can just call summary on news article or tweet, and that'll work. Yay! Similar to implementing regular methods, just after impl we put the trait name we want to implement, then use for, then specify the name of the type we want to implement for. Yeah, let me pull that up in, words, Nimish Siddle, hello, welcome to the stream. Hope that's a good way to pronounce your username. Okay. Yeah, alright. Now, we can, then we can use Rust hello on summary tweet. Yeah, Then in fun main, can let tweet equals tweet username string from course ebooks magnificent. Oh yeah, content string. I pronounced it well, yay! Horse ebooks, yeah, Horse ebooks is a name I haven't heard in fucking ages. Of course, as you probably already know, people. Reply false, retweet false, semicolon. Everything happens so much, yeah. We've got this. Wait, Horse ebooks is a name? Horse ebooks is the name of a Twitter who has not posted in forever. Let me like pull up. It hasn't posted since 2013, sadly. Yeah, they are just. They were one of the greats back in the day. Just absolute chaos and nonsense. It was very fun, yeah. That's so. Yep. Only you're off, yeah. Yeah. Horse ebooks is like on the level of drill, but not as, you know, not as drill, let's say. And print ln. One new tweet. Arise. And if I run this. Woo! Yep. Did you say drill? Yes, D-R-I-L, drill. The best poster on the website. Just absolute chaos tier shit posting all the time. Yeah, just a lot of magnificent stuff. If you don't know about drill, drill is, I think, the one good part of Twitter nowadays. Yeah. This whole thing smacks of gender, I holler as I overturn the barbecue and turn the 4th of July into the 4th of shit. Yes. Drill is, yeah, like, hydrate, thank you. All we know about drill is that they started on the Something Awful forums and have just continued to this day. Yeah. Alright. Yep. This code prints out one new tweet, horse ebooks, of course, as you probably know, people, yep. Then other traits that depend on aggregator can bring the summary trait into scope to implement the trait on their own types. Yep. Oh. Drill and horse ebooks are two of the most iconic nonsense Twitter posters out there, yeah. One restriction to note with trait implementations is that we can implement a trait on a type only if at least one of the trait... Wait. Yo! Wait! You can implement your own traits on someone else? That's cool. I like that. I like the ability to just... Yeah. I like that you can implement your own traits on someone else. That's cool. I think it's good. Yeah, and then, like, this is saying that you can't, like, implement someone else's, trait on someone else's type, which I think is fine. Yeah. That's fine, yeah. Rust is Poggies, yeah. Rust is cool! The Orphan Rule, okay, yep. Yeah. Property called coherence, okay, yeah. Other people's code can't break your... Alright, so that's just making sure other people can't break your code. Got it. Two crates could implement the same trait for the same type, and Rust wouldn't know which to use. Yeah, that'd be a problem. Default impulse, woo! Okay, you just do a default impl by just writing it, and you don't need a keyword or anything. Got it. So that would just be, string return string from read or... Yeah, something like that, okay? That's cool. I do very like... Yeah, I like traits. I like how this is set up. Use the default impl to summarize instances. Yep. Specify empty impl block with impl summary for news article. Yep. Yeah. So we're no longer defining summarize on news article directly, so I can, like, take that out. Provided the default impl. Okay, yeah. That's cool. Why did I not get the notification that Cutie Pie was live? Hello, Jasper! Great to see ya. Doesn't require us to change anything about the impl of summary on tweet and listening. Yep. Default implementations can call other methods in the same trait even if those other methods don't have a default because they all have to be defined somewhere. Good. Sounds good. Yep, to use this version of summary, you only need to define summarize author. Yep, looks good. Yeah, that's neat. Okay. Why isn't compose plus p plus I when composed for pi? Yeah, obviously, yeah. Yeah. After we define summarize author, we can call it summarize. Okay, yep. And it'll call like the definition of summarize author we've provided. Okay, yep. Makes sense, makes sense. Pretty standard, yeah. No, it isn't possible to call the default impl from an Boo! Boo! Watch enough of you. I should have bank bandwidth, but I realized compulsively stunned me out. Okay. Alright. Ah! Hi. Doing good? Good. Okay. I don't like this. That's a nitpick. You can't call super. Think there's a reason for that? Yeah, there's probably a lot of reasons for that. But I like calling super. I think it can be helpful. Yeah, to my knowledge, there's not really, like, much type inheritance in, like, beyond, like, just, unlock the rest for a bit. Yeah, like, I'm not actually sure if, like, you can, like, extend out, like, types or, traits or such. So that would probably be why, because there's not actually a built-in method for, like, inherent types beyond just a flat trait. Yeah, Rust isn't a super OP lang. Yeah. Yeah, Rust is a lot more procedural with, like, options for functional and OO. Actually, it's kind of like... Well, it's actually kind of like... yeah, it's... Nah, words. Blah, blah, blah. It's kind of a lot more like the FOO stuff that Gary Bernhardt talked about in one of his talks. Yeah. Hey, traits as parameters. Now you know how to define and implement traits. We can explore how to use traits to define functions that accept many different types. Woo! Alright, so impl is the keyword for that. So yeah, impl summary, okay, yep. And that's just borrowing it too, yeah. Yep, impl trait, got it. Neat, okay. Right, instead of concrete, yep. So we can then like do, like we could and notify item impulse summary ln post I am summarize, and we can just notify. Oh, that was a Jasper. Thank you very much for the host. I very much appreciate it. That's the line to. Wanted to save, no, whatever the fuck I almost did there. That's the line to .xcompose.txt that says multi-key pi pi. Nice. Alright. Yeah, instead of concrete type for item, we can... Oh, I've gotta borrow it. Yeah. Yay! Works. Hello, Cuddlebot. Hello, Nikki! Good to see you, babe. That, just work if I make that file? I believe there's, like, a specific, like, when compose system. Yeah. Let me skip. Ah. blush. God, y'all are not prepared for the new lemma model. It's gonna be so good. Yeah. Yep, so we specify impl keyword and trait name. Yep. Trait bound syntax. Ooh. Alright, so that's just T colon summary. Okay, yeah. Got it. So instead of an impl summary, we can do T summary and T. Equivalent to the example in the previous section, but more verbose. You place trait bounds within the declaration of the generic type parameter after colon. Yep. Impl trace convenient, makes for more concise code in simple cases, but if you want to use like a lot of things, yeah. Limited derbies. Excited for the metamorphic craft costume tomorrow. Yeah, that's gonna be fun. Gotta go, see y'all later. See ya, Jasper. Okay, but yeah. Yep, so basically if you're gonna be doing something a lot, you might want to break it out into a generic instead of using the impl syntax. There's sugar, so not super critical. Yeah. Ooh! Ooh, yo! Oh! Oh! Oh, delicious! Oh, delicious! Oh, I love that! I love that! Fuck yeah! More than one trait bound. That's tasty. Oh, you just, alright, you put it in parens there, or just use generic, yeah. Yeah, I like that. That's cool. Looks the code. Ooh, then, where syntax, okay, so... Alright, so... Too many trait bounds can just be too much, yeah. Yeah, contain lots of trait bound information between functions name and its param list, yet harder to read. So you have the where, okay, so that would be where summary. Neat, alright, I'm down for that. Yeah. Then you can return impulse summary. Return the in the return position to return a value of some type that implements a trait, and that's all you know about it instead of knowing like the impl details, okay? Using impl summary for the return type, we specify that return summarizable returns some type that implements the summary trait without naming the concrete type. Yep. Returns a tweet, but code calling this function doesn't know that. Yeah. A return a type that only specifies the trait it implements is especially useful in the context of closures and iterate. Adds a Worms keyword to our programming language. Yeah, yeah, that's like extend summary and item. It uses plus, but yeah, Captain. Yeah. Alright, good for closures and iterators, which are in chapter 13, which, oh boy, we've got a long way to go. Yeah, Now I'm excited for like learning about functional and OO language features. Oh boy, smart pointers, yeah. There's gonna be some interesting stuff. Yeah, alright. Closures and iterators create types only the compiler knows, or types that are very long to specify. But, lost interest in Rust prior through learning, yeah, might have just gone distracted. Very valid. It is messy, unsurprisingly. There's a lot to Rust. Ability to return a type. Yep. Alright. Infiltrate syntax allow you concisely specify that a function returns some type that implements the iterator trait without needing to write out a very long type. Okay. Only use infiltrate if you're returning a single type. Alright, so that's illegal. Interesting. Returning either a news article or a tweet isn't allowed due to restrictions around how the infiltrate syntax is implemented in the compiler. We'll cover how to write a function with this behavior in using trait objects that allow for values of different types in chapter 17 for OO stuff. Wait, that's illegal affairs probably, yeah. Fixing the largest function with trait bounds, okay? Right. So yeah, this is like the largest stuff from previously, so yeah. Yep, yeah, I don't have that code anymore, but yeah. And now we can use, a partial OR there. Return T, yep. Or it, yeah, or no, it said consider restricting type parameter, yeah. Yep. In the body of largest we want to compare two values of, yep. Just misheard something as partial lore. Yeah. It's partial ORed, as in order, but yeah. That was, yeah. Yeah, that was a fun largest, will now be T, partial ORed, list, and T to T, let mute largest, then, equals list O for I in list if not colon, yeah, if I greater than largest or largest, yeah. Largest was ref I return largest. There. Now that's legal because we're specifying partial order, yeah. And partial order is what we have on our Minecraft server, yeah. TFW being a mod doesn't give us a mode access. Yeah, it blows. I wish, yeah, like, there's better TTV, but like, I really wish there was a way to like, just let moderators guaranteed have remote access without subscriptions. Come on, Twitch. I do like the glowy light bulb this theme has, but yeah. Okay. Yeah. Now we get a different set of errors. We must implement copy, so... Woo! Oh! None. Yeah, thank you for gifting a tier 1 gift sub to the Sunroses. Sunrose, welcome to LMOS. The solution, yeah. I really need to think up like new like things for like bits or subs or such. Just because I'm like kind of doing a slight retheme, but yeah. Not move out of type T and non-copy slice. Yeah. Right. Definitely did copy up. Own size, yeah. All this code with only types that implement copy. We can add partial order plus copy. Yeah. There. No, don't need those, yeah. Gender. Ah. Gender. Yeah. God, I love my emotes. God, all my emotes are so fucking good. Alright, but yeah. So I've got this. And largest, yep. Love you. Love you. Ah. Trying to pick a good chat color, yeah. What Pat Pat Huggins said. Yeah, picking a good chat color is tough. Yeah. Don't want to restrict largest function to types implement copy. We can specify trait as trait bound clone. And we could clone each value in the slice when we want the largest to have ownership. Using clone means we're potentially making more heap allocs in the case of types that don't own heap data. That can be slow. Otherwise, it could return a reference to a t value in the slice. Did I go this? Ooh, yeah, that's a pretty color. I like that. Oh, posture check, thank you. Yep, wouldn't need clone or copy trait bounds, and could avoid heap allocs, yay. Implement these on your own, so yeah, so clone and anti. Would this be legal? Let's see, so let number list equals spec 34 55 100 65. Let result largest and number list println the largest number is them. Result let car list equals spec y m a q. Let result equals largest and car list println the largest car is them. Result. Run. Legal? No! Oh yeah, I forgot to borrow. Oh no, that should be a deref, yeah? This is a typing mess. Yeah, Yeah, turns of value referencing data owned by the current function, yeah. Ooh, alright, yeah. Sounds like a lifetimes thing. Let's find out lifetimes. Yep. Yeah. Or lifetimes are next. Oh, God's lifetimes, yeah. That'll be fun! Yeah, that's the part that fucks with us, yeah. This is gonna be interesting. Yeah, I would really, luckily once we get through this and test, we actually start getting to use these things in practice. Good luck, thank you! But yeah. Another way could implement largest, yep, to return, yep. Yep, if you get stuck with errors having to do with lifetimes, keep reading, yep. Lifetimes aren't required to solve these challenges, I would just need to think about how to do it better. Alright. Using a trait bound with an impl block that uses generic type parameters, we can implement methods conditionally for types that implement the specified traits. Alright. For example, type pair t in listing 1016 always implements new to return a new instance of pair t. So yeah. Yep. Yeah, recall that self is a type alias, yep. For the type of the impl block. Next block, pair t only implements the compare display method if inner type t implements partial order, enables that comparison. And the display trait that enables printing. Okay. Yeah, this is an interesting one. So yeah, let's use standard format display struct pair t x t by t impl t pair t then new x t y t to self xy then impl t display plus partial ord pair t then comp display and self if self.x greater than equals self.y println the largest member is x equals self.x else println the largest member is y equals self.y there. We can also conditionally implement a trait for any type that implements another trait. Ooh, alright. Yeah, like, you could impl t display toString for t, alright, cool, yeah. Yeah. I like that. Implementations of a trait on any type that satisfied the trait bounds are called blanket impls and are extensively used in the Rust standard lib. For example, a standard library implements toString on anything that implements display. Yep. Cool. I like that. Because standard lib has this blanket impl, we can call toString method defined by toString on any type that implements display. We can turn integers into corresponding string values because they implement it. Yep. Yay. Traits and bounds lets write code that uses generic type params to reduce duplication, but also specify to the compiler that we want the generic type to have particular behavior. Okay. Are you angry? Oh, it's not. It's FMT, not full format. Okay. Traits and trait bounds let us write code that uses generic type params to reduce duplication, but also specify to the compiler that we want the generic type to have particular behavior. Yay! Beta method syntax is pretty, yeah. I like that. I like being able to, like, call methods on literals. And I like being able to, like, put your own associated functions onto literals. That's cool. Python would have fit, yeah. Can Python do that? Yeah. You might need to, like, implement it on for... You might need to define it for, like, ints first, but yeah. And you can call methods on string literals, yeah. You'd need parens around it. Ah, yeah. Right. Yep, okay. Compiler can use the trait-bound information to check that all the concrete types used with our code provide the correct behavior. We get an error at runtime if we called a method on a type which didn't define the method. Rust moves these to compile time, yay! Additionally, we don't have to write code that checks for behavior at runtime, because we've already checked at compile time. Doing so improves performance without having to give up the flexibility of generics. Another kind of generic we've already been using is lifetimes, rather than ensuring that a type has the behavior we want. Lifetimes ensure that references are valid as long as we need them to be. Let's take a fucking look. Oh, this is gonna be interesting. Alright. Generics, yeah. A lifetime's my beloved. Alright, one detail we didn't discuss in the references and borrowing section in Chapter 4 is that every reference in Rust has a lifetime, which is the scope for which that reference is valid. Most of the time, lifetimes are implicit and inferred, just like most of the time types are inferred. We must annotate types when multiple types are possible. In a similar way, we must annotate lifetimes when the lifetimes of references could be related in a few different ways. Rust requires us to annotate the relationships using generic lifetime parameters to ensure the actual references used at runtime will definitely be valid. Yeah, annotating lifetimes is not even a concept most other programming languages have, so this is gonna feel unfamiliar. Although we won't cover lifetimes in their entirety in this chapter, we'll discuss common ways you might encounter lifetime syntax so you can get introduced to the concept. Okay. So, main aim of lifetimes is to prevent dangling references. Cause a program to reference data other than the data it's intended to. My brain is aching already, yeah. Consider 1017, which has an outer scope and an inner scope. So, let R, then let X equals 5, R equals and X, then try and access R. Now, here's where the problems begin. Yep, alright, so it's yep. So you can't reference an uninitialized variable, okay, but yeah. So, let's see what goes on. So we define R. R is in the outer scope. Then in here we define X, which is in the inner scope. Then we bind R to a borrow of X in the inner scope. Then when we go out of that, X gets dropped. And we try to reference R, which is trying to reference a variable that got dropped, and problems. This won't compile. Borrowed value does not live long enough. Yep, dropped here while still borrowed. Then borrows later here. Okay. It's time for the borrow checker. The Rust compiler has a borrow checker that compares scopes to determine whether all borrows are valid. Listing 1018 shows the same code as listing 1017, but with annotations showing the lifetimes of the variables. And this is where we start seeing why this is crimes. Rust doesn't complain that R isn't mutable, yeah. Well, that's because, R hasn't been initialized yet, is the big thing. Like, mutable just means that it can only be, or mutable Yeah, all immutable means that it can only be assigned once. Yep, Rust also has latent final variables, yeah. As long as it gets initialized before it's referenced, it's legal. Yeah. Okay. So we've got prime A. Alright, so we've got R with the lifetime of prime A, and we've got X with the lifetime of prime B, which goes down there. Yeah. Which C++ let you do that, yeah. Alright. Yep, prime A and prime B. The inner prime B block is much smaller. At compile time, Rust compares the size of the two lifetimes and sees that R is lifetime of prime A, but that it refers to memory with the lifetime of prime B. Program is rejected because prime B is shorter than prime A. Subject of the reference doesn't live as long as the reference. Alright. C++ my actually beloved. Yeah. C++ doesn't have immutable variables. Oh, wow, just at all? Consts aren't, yeah, consts are inlined at compile time. That doesn't, yeah, it's different from a variable because it doesn't actually exist. At least most of the time. Alright, yep. Const functionally means nothing. Oh, boy! Iterate, thank you. Yep. Yeah. So yeah, no, this fixes the code so it doesn't have a prime dangling reference and compiles without errors. Yep. Oh, it's immutable for optimization purposes, yep. Optimizer totally ignores const for the most part. Wow. Amazing. X has lifetime prime B, which is larger than prime A. Yep. R can reference X because Rust knows the reference in R will always be valid while X is valid. Yep. Generic lifetimes and functions. There are many other optimizations that can be done without it, yeah. Okay. So. Alright. Let's write a function that returns the longer of two string slices. This function will take two string slices and return a string slice. After we've implemented the longest function, code in 1020 should print the longest string as ABCD. Okay, probably gonna head off. Alright, see you, Sun Roses. Great to have you here. Optimizer actually already tracks what things are mutated, where not. No need for extraneous keyword fun. Well, thank you. So, let string 1 equals string from ABCD. Let string 2 equals XYZ. Let result equals longest. String 1 as stir. String 2. Println. Why is this all indented? 1 indented extra. The longest string is result. Alright, now there's a problem here. Namely, longest doesn't exist, so and longest x and stir y stir 2 and stir if x len over greater than y len, then turn x, but or else return y. Problems time. Yep, missing lifetime specifier. Yep. Function's return type contains a borrowed value, but the signature does not say whether it is borrowed from X or Y. So that means it's time for fun! Because if you passed in X and Y from two different scopes, it wouldn't know how long they're alive for. That's an issue. Return type needs a generic lifetime parameter on it because Rust can't tell whether the reference being returned refers to X or Y, and we don't know either because it is only like determined on evaluation. When we're defining this function, we don't know the concrete values that will be passed into it, so we don't know whether if or else will execute. We also don't know the concrete lifetimes of the references that'll be passed in, so we can't look at the scopes as we did in listings 1018 and 1019 to determine whether the reference we returned will always be valid. Problems. The borrow checker can't determine this either because it doesn't know the lifetimes of X and Y relate to the lifetime of the return value. To fix this error, we'll add generic lifetime parameters that define the relationship between the references so the borrow checker can perform its analysis. Lifetime annotations don't change how long any of the references live. Just as functions can accept any type when the signature specifies a generic type, functions can accept references with any lifetime by specifying a generic lifetime parameter. Alright, lifetime annotations describe the relationships of the lifetimes of multiple references to each other without affecting the lifetimes. I have a slightly unusual syntax. Names of lifetime parameters must start with an apostrophe and are usually all lowercase and very short like generics. Most people use prime A. Okay. You place lifetime parameter annotations after the and of a reference using a space to separate the annotation from the reference's type. Okay. One lifetime annotation by itself doesn't have much meaning. Looked it up and I get it now. Constantly like a non-mutating view, yeah. Alright. Doesn't have much meaning because the annotations are meant to tell Rust how generic lifetime parameters of multiple references relate to each other. For example, let's say we have a function with the parameter first that's a reference to an I32 with lifetime prime A. The function also has another parameter named second that is another reference to an I32 that also has lifetime prime A. Lifetime annotations indicate that the references first and second must both live as long as that generic lifetime. Yep. Let's examine lifetime annotations and longest, okay. Declare generic lifetime parameters inside angle brackets between function name and parameter list, so that'll be the prime A. Then let's X prime A. Alright. Stir Y prime A stir. And prime A stir. Alright. This code should compile and produce the result we want. Let's see. Did I fuck it up? Alright, I've got weird libera stuff. Okay, yeah. Yay, works! You know, I'm just gonna delete y'all for now. Don't need it. Alright. Code should compile and produce the result we want when we use it. Yay! Function signature now tells us that for some lifetime prime A, the function takes two parameters, both of which are string slices that live at least as long as lifetime prime A. The sig also tells us that the string slice returned will live at least as long as lifetime prime A. Means the lifetime of the reference returned by the longest function is the same as the smaller of the lifetimes of the references passed in. These relationships are what we want Rust to use when analyzing this code. Alright. Remember, when we specify the lifetime parameters in this function sig, We're not changing the lifetimes of any values passed in or out. Rather, we're specifying that the borrow checker should reject any values that don't adhere to these constraints. It is all type checking. Note that the longest function doesn't need to know exactly how long x and y will live, only that some scope can be substituted for a primate that will satisfy the signature. Okay. Alright. When annotating lifetimes and functions, annotations grow in the function sig, not in the body. Lifetime annotations become part of the contract of the function, much like the types in the signature are. Adding function signatures that contain the lifetime contract means analysis of the Rust compiler can be simple. If there's a problem with the way a function is annotated, the compiler errors can point to the part of our code and constraints more precisely. If it made more inferences about what we intended, it might only be able to point to a use of our code many steps away from the cause. Alright. When we pass concrete references to longest, specifically cons can point to alias memory that can be modified underneath the view and has no guarantees of immutability. This is why Rust tries so hard to be memory safe, because otherwise you can't make immutability guarantees like this and still provide pointer access. Yeah. Alright. Okay. Yep. Concrete lifetime substituted for primates part of the scope of X that overlaps with the scope of Y. Alright, generic lifetime primate will get the concrete lifetime that's equal to the smaller of the lifetimes of X and Y. Because we've annotated the returned reference with the same lifetime parameter, primate, return reference will also be valid for the length as smaller of the lifetimes X and Y. Okay. You want to know what feels like would be a really good thing for, like, visualize for, like, Rust stuff? I still like C and C++ because I personally find memory safety to be too high of a constraint for the kinds of programs I like to work on. Yeah. That's fair. Yeah, like, there was actually a post I saw about this a little while ago, is that, like, the primary people who are, picking up Rust are not actually, like, C or C++ devs that want to write safer code. They're JavaScript devs who want to write faster code. And I think that's really, really interesting. Yeah, like, I think that's just an interesting thing to note about Rust, is that, like, yeah, it may be, like, intended for, like, C or C++ devs, but, like, with the WASM export, like, Rust is just it replaces JavaScript better than it replaces C, and I think that's really interesting. Big benefit of Rust is that its toolchain provides a built-in WASM compiler with some scripting. Yep. It's good. Yeah, or without inscripting. Yep. Yeah. Yeah. Yeah, I think, like, I think that's, like, a really good thing for Rust, is that, like, sure, you can use it, like, for a C or C++ alternative, but, like, it just works a lot better as a JavaScript alternative, for a Python alternative or such. Like, yeah, you have to think about more stuff, but you get a lot faster code. If you want to build C or C++ to WASM, you gotta use Clang with them scripting, which is a pretty huge step, yeah. Let's look at how the lifetime annotations restrict longest by passing in refs that have different concrete lifetimes. Okay. So here's what we're gonna do. Oh, and then that. There. Yeah. I think there's, like, one thing I think would be, like, really, really cool to have with, like, a Rust Analyzer plugin or something, which, are there... Tax tree. It doesn't look like it does, but yeah. And Golang Dwasm is horrible, don't even get me started. Oh boy. Yeah. Yeah. I think a big thing I would like to have for, like, a Rust Analyzer stuff, such is, like, annotating, like that comment view of lifetimes that it showed earlier, like this. I would like Rust Analyzer that, like, has, like, a layer for that. I think that'd be very, very nice. Yeah. Doesn't even scripting, but it bloats so easily, yeah. Yeah, I think it would be good to have, like, a visualization of lifetimes. That would be a big help. Yeah. Rust lifetime errors have lines kind of like that, yeah, but, like, yeah, like, I know the errors do, but, like, I also want to see that, like, on the editor screen, not just in, like, the, errors. Yep. String 1 is valid until the end of the outer scope, string 2 is valid until the end of the inner scope, and result references something that's valid until the end of the inner scope. You'll see that the bar checker approves of this code, it'll compile and print. Yep, this is legal! Are you sure that isn't a setting in the plugin? It might be, settings, extensions, Rust Analyzer. Cargo, okay. Check on save, okay. Completion. Debug. Engines, yeah. Map, warning is hint, warning is info. Rock outer macros, okay. Alice watcher highlighting. Strings, breakpoint, exits, references, build points, documentation. Yep. Cover actions, annotations, yep. References, training hint. Inlay hints, okay. Join, alright, joins. Lens, okay. Yeah, there's code lens, that might be it. Of course, custom command scene with variant references, implementations, refs, references on. It doesn't, yeah, it sadly does not look like it has a lifetime lens. Oh well. Oh. Yeah, having a Rust like lifetime lens would be neat. Oh well. Okay. Now this is illegal. Because, alright, so... yeah. Like, just looking over this, I can tell it's illegal because these two are set out here, but this is like the lifetime because it's always the smallest lifetime. Yep, got it. That's illegal. We can look at this code, see string 1's longer than string 2, and result will contain a reference to string 1. However, the compiler can't see that the reference is valid. Told Rust that the lifetime of the reference returned by the longest function is the same as the smaller the lifetimes the reference is passed in. That is just like a, yeah, sad thing about static analysis is that, like, even for things that, like, can somewhat be hard-coded, it's just not really always enough. But yeah. Alright. Thinking in terms of lifetimes, okay. Yep, depends on what your function's doing. If we change the implementation longest to always return the first parameter, wouldn't need to specify a lifetime on Y because it doesn't matter. Yep, lifetime of Y doesn't have any relationship with lifetime of X. Alright. If the reference return does not refer to one of the parameters, it must refer to a value created within the function. Yep, which would be dangling. Yeah. Needs to match one of the inputs, or it just doesn't really know what to reference off of. Huh. Result goes out of scope, yep. At the end of the longest. So yeah, like... Quick look online shows that there are a few projects add lifetimes and bar visualizers to Rust language service. Not sure about their status, yeah. Alright. I also wouldn't want to use one of those when I've only got like half the screen to actually see Rust. Next track. Lifetime annotations in struct sweet. It's possible for structs to hold references, but we would need to add a lifetime annotation on every reference in the struct's def. Alright. Alright. So, one field part that holds a string slice, which is a reference. Declare the name of the generic lifetime parameter inside the angle brackets. Yep. This annotation means that important excerpt can't outlive the reference it holds in part. Got it. A lot of them are using highlighting and outlining rather than external lines. At least that's what's being shown. Yeah. That'd probably be good. Yeah. Okay. Yeah. Creates an instance of important excerpt. Yep. Data novel exists before the important excerpt instance is created, and it doesn't go out of scope until after it goes out of scope, so it's still legal. Woo! Lifetime elision. Okay. Learn that every reference has a lifetime, and you need to specify lifetime parameters or functions or structs that use them. We had a function in listing 4.9, which is shown again in listing 10.26. That compiled without lifetime annotations. Why? Historical, oh boy. In pre 1.0, yeah, when I compiled everything. After writing a lot of Rust code, found that Rust programmers are entering the same lifetime annotations over and over in particular situations. These situations were predictable and followed a few deterministic patterns. To develop programmed these patterns into the compiler so the bar checker could infer. Better than historical because it's handy, yeah. Hey, piece of Rust history is relevant because it's possible more deterministic patterns will emerge and be added. Even fewer lifetime annotations might be required. Patterns programmed into Rust analysis of references are called the lifetime elision rules. That rule is for programmers to follow. There are a set of particular cases the compiler will consider. Like, if you have something that, if you have a function that takes one argument and that takes one borrow and returns a borrow of the same type, you can safely assume that you can, or the compiler can safely assume that they'll just want the same lifetime. That's cool. Elision rules don't provide full inference. If it deterministically applies the rules, but there's still ambiguity as to what lifetime the references have, the compiler won't guess what the lifetime of the remaining references should be. Yep. Compiler will just give an error and tell you to do it by yourself. Alright, there are three elision rules right now, okay? First rule applies to input lifetimes. Second and third apply to output lifetimes. If the compiler gets to the end of the three rules and there are still references for which it can't figure out lifetimes, it'll stop with an error. These rules apply to fun definitions as well as impl blocks. Each parameter is a reference that gets its own lifetime, okay? A function with one parameter gets one lifetime parameter, fun foo prime A, yep, prime A, I32. Function with two parameters gets two separate lifetime parameters, prime A, prime B, and so on. Second rule is that if there is exactly one input lifetime parameter, that lifetime is assigned to all output lifetime parameters, okay? Got it. If there are multiple input lifetime parameters, but one of them is AndSelf or AndMuteSelf because it's a method, the lifetime of self is assigned to all output lifetime params. Third rule makes methods much nicer to read and write because fewer symbols are necessary. Yay! Yeah. Let's take a look at that. PewDiePie one. Woo! Yeah, you got it set up. Alright, so. Signature, first word. Alright. S, Anster to Anster, so that's, yeah, so first rule, each parameter gets its own lifetime, so that's S and prime A. One output lifetime, so it's S prime, yeah, so it's M prime A. Now the references in this function, signature of lifetimes, yep. This time, longest, yep, so that's prime A, prime B. But the second rule cannot apply, so you've gotta deal with it yourself, okay. Then, lifetimes and method defs. Method signatures inside of impl, and method signatures inside of impl references might be tied to the lifetime of refs in the structs fields, or they might be independent. In addition, lifetime elision rules often make it so that lifetime annotations aren't necessary in method segs. Let's look at some examples using the struct named important excerpt that were defined in listing 1025. Yep. So we've got, yep. Alright, so impl prime A, important excerpt prime A. Then we'll use the method named level, whose only parameter is a reference to self and whose return is an I32. Alright. Lifetime param deck after impl and its use after the type name are required, but we're not required to annotate the lifetime of the reference to self because it's because of the first elision rule. Yay. Alright, so here's the third one. So you've got and self, announcement and stir to and stir. This will have the lifetime of and self. Got it. Static lifetime, which means it's here forever. Woo! All string literals have and prime static, which makes sense because they're hard-coded in the binary and are gonna be there forever. Might see suggestions to use static lifetime in error messages. Before doing it, think about what you're doing, whether it actually lives the lifetime of your entire program or not. Consider whether you want it to live that long, even if it could. Most of the time, the problem results from attempting to create a dangling reference or a mismatch of the available lifetimes. solution is fixing it, not specifying prime static. Prime static can lead to memory bloat, so avoid it if possible. Alright. Generic type parameters, trait bounds, and lifetimes together, okay. Alright, yay, that's a lot of stuff, Jesus. I'm gonna write this one out, so use standard format display, then longest with an announcement prime a p open paren x and prime a stir y and prime a stir and p yep 2 and prime a stir where the display. Jesus Christ. That's one hell of a method signature, I've got to say. Alright, then println announcement. Ta-da. And if x len greater than y len, return x, else return y. That is one hell of a method sig, I've got to say. I'm like, I understand why it's being split up on a lot of lines, but I don't like it. We're gonna just and then yeah, that is one hell of a method signature. It's good god, that is one hell of a method signature. Extra parameter will be printing using format, which is why display trait bound is necessary. Because lifetimes are a type of generic, the decks of lifetime parameter prime A and generic type parameter T go in the same list inside the angle brackets. Okay. Covered a lot in this chapter. Now that you know about generic type parameters, traits, and trait bounds, and generic lifetime parameters, you're ready to write code without repetition that works in many different situations. Generic type parameters let you apply code to different types. Traits and trait bounds ensure that even though the types are generic, they'll have the behavior the code needs. You learned how to use lifetime annotations to ensure that this flexible code won't have any dangling references. And all of this analysis happens at compile time, which means no worry about runtime performance. Yeah, you can do t:\display. Yeah, you can indeed. That shortens it. Yeah. Believe it or not, there's much more to learn on the topics we discuss in this chapter. Chapter 17 discusses trait objects, which are another way to use traits. More complex scenarios involving lifetime annotations you'll only need in advanced scenarios, which you should read the Rest reference for. Next, you'll learn how to write tests in Rest so you can make sure your code is working. Before we get on with this, I am going to take a quick couple-minute break just to stretch, get a bit more water, stuff like that. I will be right back. See you soon. I'm back. Hello, everyone. Today's a sleepy day for some reason. Just kind of low energy and chill. Alright, but yeah. It's testing time. Yeah. You know, program testing is a very, can be a very effective way to show the presence of bugs, but it is hopelessly inadequate for showing their absence. Alright. Correctness in our programs is the extent to which our code does what we intend it to do. Alright, yep. High degree of concern about the correctness, but correctness is complex and not easy to prove. Rust type system shoulders a huge part of this burden, but the type system cannot catch every kind of incorrectness. As such, Rust includes support for writing automated software tests. Woo! Here's hoping they'll actually work for me, because I have tried using, like, testing suites in other languages, especially Java, which craft modding, and Python, and Jesus fucking Christ, I've never gotten them to work for me. I have no idea why. I'm just cursed or something. Alright. Type system cannot catch every kind of incorrectness. That means we gotta do some work. Yep, we write a function called add2. Yep, that's an integer and returns an integer. Rust does all the type checking and bar checking to make sure that's correct, but it can't check that this function will return the parameter +2. Like, we need to make sure of that ourselves. It can write test that assert, for example, when we pass 3 to add 2, it returns 5. But we cannot test, but it is computationally impossible to test every possible input parameter, so we've just got to trust that we can do what we can. Okay. Although we can't cover every detail about how to write good tests, we'll discuss the mechanics of Rust testing facilities. We'll talk about the annotations and macros available to you when writing your tests, the default behavior and options provided for running your tests, and how to organize tests into unit tests and integration tests. Okay. So, bodies to test functions typically perform 3 actions: set up needed data and state, run the code you want to test, and assert the results are what you expect. Let's look at the features Rust provides specifically for writing tests that take these actions, which include test attribute, a few macros, and should panic. Okay. Okay. Alright, time for attributes. Alright. Which are like annotations in other languages. So yeah, attributes are metadata about pieces of Rust code. So there's derive, which we used in chapter 5. To change a function into a test function, add hashtag test on, in front of it. Yeah, we'll just do this here. When you're running tests with cargo, test command Rust builds a test runner binary that runs the functions annotated with test. Yep. Test module with the test function is automatically generated for us. I don't know where. Oh yeah. Alright, so. Yeah, source librs, alright. Alright, so. Hashtag open config test. Mod tests. Hashtag test. Then it works. Assert ek 2 plus 2 4. Alright. There. No, test annotation before fun. Yep. Ba-ba-dum. Up there. Yep. This attribute indicates this is a test function, so the test runner knows to treat this function as a test. We could also have non-test functions to help set up common scenarios, so we need to indicate which functions are tests by using the test attribute. Function body uses assert ec macro to assert that 2 plus 2 equals 4. Serves an example of the format of a typical test. Yay! I can just click the run test button here. Awesome. Nice! Very cool. Yeah, having just like a one-click button to run tests in Editor is a great thing. I like the Rust Analyzer plugin. I think all IDEs should be like that. I wish I didn't have to use an IDE running Electron for that, because having just a click here to do it thing is good. Alright. Let's ignore the top 2 lines and focus on the function to see how it works. Test annotation before we find... Oh, I read that one, didn't I? Yep. Uses assert ec macro that to assert that 2 plus 2 equals 4. Is there like a... F12, okay. Oh, hey! Alright. That's a lot. Okay. Yeah. I like being able to just click in. Can I actually... where do I do... I'll figure out key bindings later. I'd like to... Like, I'm used to Control B for that. Yeah. This code is running Electron, though? Yeah, it's heavily customized and optimal. Yeah, no, like, just... I wish it didn't require using Electron. Yeah. Yeah. Like... I wish there was something, like, a bit more native down instead of having to trust Google to do something. Yeah. Alright, yep, assert ec, yeah. And you don't have to trust Google. Yeah, but, like, I wish, like, there was an editor that, like, had all this convenience but wasn't dependent on CEF. Yeah. VS Code uses their own build of Electron, yeah. But, like, it's still... Electron is still fundamentally the Chromium embedded framework. Like, that is still on the stack, and I don't like it. Like, I wish that I didn't have to use a web browser to write code. Yeah, alright, so cargo test, yep. Yeah, so I can just click that and it'll just do it there. That's very cool. Cargo compiled and ran it, yep. Next line shows the name of the generated test function. Called it works. Hopping in, again to say goodnight. Sweepy Coyotes, sweepy off. Care package by the door though. Alright. Thank you, Jasper. I hope you rest well. Yeah, it is kind of just a sleepy night tonight for some reason. Hydrate, posture check, and stretch. I appreciate it. Yep, alright. Test result okay means that all tests passed. As we don't have any tests we've marked as ignored, summary shows 0 ignored. Yay. We haven't filtered the test being run, so the end of the summary shows O filtered out. Nice. O measured is for benchmark tests that measure performance. Benchmark tests are, as of this writing, only available in Nightly Rust. Wee. Okay. Yeah, there are benchmarks coming. Alright, then doc tests adders to the result of any doc tests. Don't have any, but Rust can compile any code examples that appear in our API docs. Woo! Alright. Change the name of our test, see how that changes the output. I like how that also saves you, but yeah. That just changes it to test exploration, yep. Yeah. Looks good. Now, we'll make a test that fails. Alright, so, test, then another panic, make, test fail, then you are not happy, Yep, test failed. And that just gives us the call stack. Okay, yep, good. Alright, so yeah. I also like that it's got like individual like run test buttons. I like editor layers. I think they're good. Yeah, okay. Got some stickers and stuff I should use around here. Yep, exploration passed and another failed. Yep. Another, or test another shows failed. Alright. Alright. There's controlling how tests are run, yep. Summary line displays at the end over all our test result is failed. Had one test pass, one test fail. Now that you've seen what the test result looks like in different scenarios, let's look at some macros other than panic. So there's assert, which just tests that something is true. If true is assert, does nothing and passes. If it's false, panics. Using assert helps us check our code. What the fuck does panic look like? Oh, compiler built in, okay. Compiles to create panic 21 or create panic 2015, depending on the addition of the caller. Got it. Alright. Values false assert, yep, cause panic. Then we use a rectangle struct and can hold method, so let's just make that again. Alright, derive debug struct rectangle width u32 height u32 impl rectangle fun can hold and self other and rectangle to pool return self dot width greater other width and self height greater than other height. Alright. Then, yep, returns a boolean, so perfect for assert. Then use super boom. Then test fun larger can hold smaller, but larger equals rectangle width 8 by 7. let smaller equals rectangle, width 5, height 1, assert larger can hold and smaller. It's good, yay! Ah, that's good. Alright, it works. I want a clicky keyboard for this machine. And for my desktop, I would really like an RGB clicky keyboard. That'd be fun. Not sure if I'd want to keep the low profile chalk keys I've got or something else, but yeah. Yep. So use super test module as a regular module, follows the usual visibility rules. Yay. Test module is an inner module and need to bring the code under test into the outer module, or in the outer module into the scope of the inner module. Use a glob here, so anything we define in the outer module is available. Good, that's how it should be, but yeah. Alright. Yay, tests. Created the 2 rectangle instances we need. I'm having a language with built-in testing is pretty good and helpful. I think languages providing a built-in testing suite instead of having to worry about which one of a ton that is community implemented is good. Same with build systems and such. Having that stuff stock is good. Yep, assert. Yep, larger can hold smaller. It's supposed to return true, so our test should pass. Let's find out. Yay, passes. Good. Then let's make another test. Test. Then smaller cannot hold larger. Let larger. Yeah, this would be let's fun construct rects to rectangle. Then I can just copy this out, return larger, smaller as a tuple. Then let larger, smaller equal construct construct rects. Not dead. Yeah, oh. Yeah, don't worry. Larger, smaller, equal, construct rects. Assert, not smaller can hold, and larger. There. Now if we run tests. Woo! Both work! Something wrong with how this is mapped. Oh yeah, there's just stuff off screen. Okay, yeah. There. I am happy with being able to is there a way to hide that? I don't know. Oh well. Yeah. Nice, I remembered how tuple returns work. Awesome. Alright. Yep. Do test the pass. Or you. Just alright. Oh yay, UB. Alright, when we introduce a bug into our code. So if we swap these, then we can run. Tests failed. Oh no. Smaller cannot hold larger. Alright. Yep. That's upset. Okay, yep. Assertion failed. Larger can hold smaller. Alright. And if we switch that back, it should be legal again. Oh, does it say dead code if it's only used in tests? Huh, interesting. Okay. Testing equality with assert ec and assert not ec. Yep. Alright, so any is... yeah. So, yep. Not equals, okay, yeah. So, now we can, add 2 a 2 to my 32, return a plus 2. Yep, then, test, then it adds 2, assert ec 4, add 2, 2. Alright. Then run that one. All good. Yay. Alright. But if we change it to +3 and run. Failure. Alright, yay. Test-driven development. This is such a good testing suite, TBH. Alright. Some languages and test frameworks, the parameters to the functions assert two values are equal are called expected and actual. Order in which we specify them matters. However, in Rust they're called left and right. Order in which we specify the value expected and the value code under test produces doesn't matter. Yeah, we could assert write assertion as add to 2 and 4. Yep, doesn't matter. It is just checking equal or not equal. Yep, alright, so it's just equal, equal, and not equal, yep. Which means must implement partial ec and debug. Alright. All primitive types and most of the standard library types implement these traits. You'll need to implement partial ec to assert values are equal and not equal. You need to implement debug to print values when the assertion fails. Both traits are derivable. Woo! That's very helpful. So that's just hash derive partial ec debug. Yeah. Like I could impl partial ec or rectangle. What do you define? Alright, so that's... Yep, or no, I can derive that one, yeah, no, I'm thinking of order for that one, yeah, so... Partial ec, yeah. Alright, yay. Custom failure messages. You can add a custom message to be printed with failure set. Any arguments specified after the one required arg to assert or 2 to assert ec and assert nay. Alright, are passed along to format. Yep. Okay, makes sense. Alright, yeah. So we want to have function greets people by name. We want to test the name, pass, and function. Yep. Requirements haven't been agreed upon yet. I'm pretty sure hello text at the beginning of the greeting will change. You don't want to have to update the test when the requirements change. So instead of checking for the exact quality, yeah, we'll just assert output contains. All right. Yep. to introduce a bug. I love the little Ferris markers in the book. They're very good. Yeah, let's pub, then greeting, name, and to string, return format, hello, but name, name, then hash test, button. Contains name, let result equals greeting, lemma, assert, result contains lemma. There. Run test. Yay! Alright, good stuff, good stuff. And then we can also greeting did not contain name. Value was result. And I can run that again, and that'll fail and tell us why. Oh, that was just a full non-comp. Okay, yeah. Alright, so yeah, it won't actually let us compile format macro, so that's safety, yay! Yeah, never put off, never put off to runtime that which you can, do during compile. Yeah. But I can, return string from hello. Now if I run this test, it will error there, yep. Yep, test failed, yep. Yeah, it warns about the unused variable, and then like, yep, boom. Alright. Woo! Then checking for panics with should panic. And then we've got like the guest stuff from a little while back that will have should panic, which is just another derived macro which will see if it panics. Hooray! Cool. Or not derived, but yeah, that's like an attribute macro. Okay, yeah. Yep, okay. The panic failed. Test did not panic as expected. Should panic can be imprecise because they only indicate the code has caused some panic. Should panic test would pass even if the test panics for a different reason from the one we were expecting to happen. To make should panic test more precise, we can add an optional expected parameter to should panic. So yeah, alright, yeah, with error, yeah, with like an expected text. Okay. Okay, that's cool. Yeah. Alright. That's helpful and neat. Alright, then this is UB, yeah? Yeah, this is UB because you've swapped those, which is not good. Alright, yeah, which would fail the test. Okay, yep. Ooh, results in tests, okay. Ooh, you can, do a result unit string, okay. And, yep. And then it will use that for the test instead, okay. Cool, like that. Let's use question mark operator, yay. Alright, yep. Convenient way to write tests that should fail if any operation in them returns an error, okay, yep. And you should panic variance on result because you should just return an error. But yeah. Now that you know several ways to write tests, let's look at what's happening when we run our tests. Woo! Time to look at the what, why, and how. That's one of the great things about the Rust book is that, like, it tells you, like, how stuff's working, not just, like, programming tutorials are supposed to teach you 3 things. What, why, and how. And Rust is one of the few things that I've found that does that. Like, it should tell you, like, what to do, why to do it, and how it works, at least somewhat. But yeah. It is, like, just very good to have something like that. Okay. Alright. Just as cargo run compiles your code and then runs the resulting binary, cargo test compiles your code in test mode and runs the resulting test binary. Yeah, like, just, I would really like to, like, just, I would like to see, like, more programming language tutorials, like, talk about, like, the how stuff actually works. Like, you don't really, like, one thing I kind of wish that, like, Rust talked about is, like, the how it chooses main to be your, like, or, like, it never really does the why or how of why you, of, like, putting stuff in main. It just says the what of, hey, the code you run at start goes in main. It doesn't tell you why or how, and I think that is a thing that it should, like, at least mention, you know? Yeah. Default behavior of binary produced by cargo tests is to run all tests in parallel and capture output generated during test runs, okay? Preventing the output from being displayed and making it easier to read the output related to test results. Some CLI options go through cargo tests, some go to the resulting test binary, yep. Well, it's the arguments that go into cargo tests followed by the separator, the ones that go to the test binary. Okay, yeah. So cargo test -- help displays options you can use with cargo test, and then cargo test -- space -- help displays the options you can use after the separator -- Alright. When you run multiple tests, they run in parallel using threads. Means the test will finish running faster so you can get feedback quicker. Because the tests are running at the same time, make sure your tests don't depend on each other or on any shared state, including a shared environment, such as the current working directory or environment variables. Whee! That's good for unit tests. Maybe not for integration tests, but integration tests are a bit of a scam anyway. Yeah. Yep, let's say each of your tests runs some code that creates a file on disk named testoutput.txt. Write some data to that file. Oh, where did that go? Then each test reads the data in that file and asserts that the file contains a particular value, which is different in each test. Because they run at the same time, one test might overwrite the file between when enough a test writes and reads the file. That's bad. Second test will then fail, not because the code is incorrect, because the tests have interfered with each other while running in parallel. So then you can, yeah, so one solution is to make sure your test writes to a different file, other is to run tests one at a time. Then you can use the test threads flag, okay. Nice, nice. Okay, yep, so that's number threads to 1. That's cool, like that. Spelling program did not use any parallelism, yep. Showing function output, okay. Alright, so here's a panic. Yep. Yep, okay. Test passes Rust test library captures anything printed as standard out. Yep. If we call println in a test and test pass, we won't see the println. Yep, we'll only see the line that indicates test passed. Test fails, we'll see whatever was printed as standard out with the rest of the failure message. So yeah. Still a function prints the value of its parameter and returns 10, as well as a test that passes and a test that fails. Alright. When we run these tests with cargo tests, we'll see the following output. Alright. Hello, Rempower! Great to see you! Yeah, this doesn't actually print anything. It will have a failed test, yep. So we've got to use show output, got it, okay. Makes sense. Probably a way to do that with, like, this stuff. Yeah, probably. How are you? I'm doing pretty good. I'm learning how to use the Rust programming language, which is very neat and very interesting. I'm doing my best to understand it. It's a bit of a lot, but I think I'll get the hang of it. All right. All right. There. Running subset of tests by name. Alright, so yep. If we want to run like individual tests, yep. We can pass the name of any test function into cargo test. I can also just use this button here. Yeah. Alright, only the test with the name 100 ran. Other two tests didn't match that name. Yay. Makes sense. Filtering to run multiple tests. Filters, okay. Alright, so because two of our test names contain add, we can run those two by running cargo test add, okay. Yep. Debugger, stop. Don't care right now. Go away. Yeah. Alright, then that'll just, yeah, filtering will just be like that, okay. Ignoring some tests unless specifically requested. Yeah. Alright, so that's just like ignore attribute, okay. Got it. Code that takes an hour to run, yeah. Now we can just like mark those as ignored, then run them on our own time. Alright. Got it. Yeah. Okay, so yep. One run only the ignored test, we can use cargo test ignored, okay. By controlling which tests run, you can make sure your cargo test results will be fast. Near a point where it makes sense to check the result of the ignored tests, you can use -- ignored. Awesome, cool, yay. Test organization, woo! Alright, there's a couple big kinds of tests, unit and integration. Yep, alright. Both kinds of tests important, yeah. Purpose of unit tests is to test each unit of code in isolation from the rest of your code to quickly pinpoint where code is and isn't working as expected. You'll put unit test in source, yep, and just like, yeah, in each file with the code they're testing, just create a test module and annotate with config test. Alright. Then config test annotation, test module tells Rust to compile and run the test code only when you run cargo test, not when you run cargo build. Saves compile time. Alright. Yep. Save space because tests are not included. Because unit tests go in the same files as the code you'll be using, config tests to specify they shouldn't be included in the compiled output. Yeah. Although when we generated the new adder project in the first section of the chapter, cargo generated all that code for us. Yep. Yeah, config test and... Alright, private functions! Debate within the testing community about whether or not private functions should be tested directly. Other languages make it difficult or impossible to test private functions. Regardless of which testing ideology you adhere to, privacy rules do allow you to test private functions. Okay. Yep. Internal adders not marked as pub. Tests are just Rust code, and test module is just another module. Yep. Items in child modules can use items in ancestor modules even if they're not. Yep. Even if they're not public. Okay. All the test modules parent items into scopes with use superstar. Then, yep. Internal adder. Yep. Don't think private functions should be tested. Nothing in Rust will compel you to do so. Yay! Integration tests. Alright, I like that. Alright, I like the split of like having unit tests alongside your code and then integration tests external. I think that's really good instead of like having all your test code in like an external area. I like Rust testing system. This is good. This is usable. They use your library in the same way any other code would, which means they can only call functions that are part of your library's public API. Their purpose is to test whether many parts of your library work together correctly. Units of code that work correctly on their own could have problems when integrated, so test coverage of the integrated code is important as well. To create integration tests, you first need a tests directory. Alright, yep, just up next to source. There are notes to look for integration test files in the test directory. Okay, yeah. And then make as many test files as we want. Yay! Cargo will compile each of the files as an individual crate. With code listing 1112 still in the source librs. Yep. Yeah, Alright, so now I can do that, so, Alright, so new folder, tests, and, integration tests, or SRS, not TypeScript Rust yet, then use, Rust hello, hash test, then it adds to assert ec for add Rust hello add to. Now if we run, woo! Don't care about that. Okay, so yeah, it grabs all of that. All right. Alright, yay, finished. Yep, integration test. Woo! Awesome. That works, yay. It added use adder to top the code. Didn't need in the unit tests. Crash, okay. Yeah, it's fine. We're getting towards the end of the stream anyway, but yeah. Yep, so use there, yep. Then don't need to annotate because it's already in the config, or because it's already in the test directory, okay. Cargo treats the test directory specially and compiles files only when we run cargo test, yep. Yay! 3 sections of output include the unit test, integration test, and doc tests. First section for unit test, same as we've been seeing, 1 line for each unit test, okay. 1 named internal we added in listing 11.2, summary line for unit test, okay, yeah. Oh hey, there's analysis, okay, yeah. Yeah. Ah. Alright. Yay! Alright, so starts with line running, yep. Yeah. Okay, got it, yay. Yep. Line for each test in the integration test, summary for the results. Alright, yay. Similarly, adding more unit test functions, add more result lines to the unit test section. Adding more test functions to the integration test file adds more result lines to this integration test file section, yep. Each integration test file has its own section, so if you add more files and tests, yep. We can still run particular, yep. Just run integration test, okay. Submodules! Ugh! Might want to make more than 1 file and test to organize them, yep. Treating each integration test file as its own crate useful to create separate scopes. This means files in test directory don't share the same behavior as files in source do. Different behavior of files in test, most notable when you have a set of helper functions that be useful in multiple integration test files, okay. Recreate test common RS and place a function named setup in it, yep. You'll need to see a new section in test output for common RS, okay. Alright, how do you deal with that? Okay, yeah. Common with running 0 test, no we wanted. So we'll create test common mod RS, okay. Alternate naming convention. Naming the file in this way tells us to create it as a module, okay. Got it. Yep. We can use it from any of the integration tests as a module, yay. Got it. Cool, helpful. Integration test for binary crates. Got it, yep. Can't create an integration test in tester, bring functions defined in source main RS. Only lib crates expose functions that other crates can use. One of the reasons Rust crates that also provide a binary have a straightforward source main RS that calls logic libs in source lib RS, yep. Using that structure, integration test can test the library crate with use to make the important functionality available. If the important functionality works, a small amount of code in source main RS will work as well. That small amount of code doesn't need to be tested. Woo! Okay. Let's do a project! Chapter is a recap of the many skills you've learned so far and an exploration of a few more standard lib features. We'll build a command line tool that interacts with file and command line input and output to practice some of the Rust concepts you now have under your belt. Rust speed, safety, single binary output, and cross-platform support will make it an ideal language for creating command line tools, so for our project we'll make our own version of grep, okay. Alright, very cool. Reads the file, finds a line that matches the string argument, prints those lines. Show how to make our command line tool use features of the terminal that many command line tools use. Read value of an environment variable to allow user to configure behavior. Print error messages using standard error instead of standard out, so they can redirect output to a file while still seeing error messages on screen. Yep. One Rust community member has already created a fully featured, very fast version of grep called RipGrep. Our version will be fairly simple, but this chapter will give you some of the background knowledge to understand a real-world project. Okay. This will be using organizing code with modules, using vectors and strings, handling errors, using traits and lifetimes, and writing tests. We'll also briefly introduce closures, iterators, and trait objects, which chapters 13 and 17 cover in detail. Okay. Let's go. Not. Fuck it, I'm gonna just, you know what, fuck it, I'll do it here, so, let's, so yeah, you know what, I want to make a new one, so, just in case it accidentally, like, lets slip my, like, username stuff, I'm gonna quickly, terminal, cd, cargo, new mini grep. Alright. Alright, I'm gonna close that. That was in documents, Rust, mini grep, source, yeah. I'll open this in VSCode. Oh, whoops! Thank you, Rempire. I don't know why they didn't show up on my other screen. VSCode. Okay. Select. Alright, yes, I trust the authors. The author's me. VSCode. Hello? VSCode. There. Go away. Alright, main RS. Yeah, something is... My laptop is not happy right now, Jesus Christ. Reload, please. Alright. So, here we go. Alright. So, first task is to make minigrep accept its 2 command line arguments, file name, and a string to search for. We want to be able to run our program with cargo run, a string to search for, and a path file to search in like so. Okay. Program being generated by cargo noob cannot process arguments we give it. Some existing libs on credits.io can help with writing a program that accepts command line arguments, but because you're just learning this concept, let's do it ourselves! Not invented here. Okay. Alright. So, we're gonna start with use standard env. Alright, then we're gonna let args, which is a vec string, equals env args elect. Then we can just println args. Alright. Then tell it terminal. Alright, then we can cargo run search string example file name txt. Alright, alright, so minigrep, then search string example file name txt. Okay. Got it. I wonder if there's like a way to like configure what that run command is gonna be. Alright, yep. So use statement, yep. Standard env args, yep, is nested in 2 levels of module. Where the derive function It's conventional, bring parent module into scope rather than the function. Less ambiguous, woo. Args function an invalid Unicode. It will panic if any argument contains invalid Unicode. If your program needs to accept arguments containing an illegal Unicode, use args OS instead. That function returns an iterator that produces OS string values instead of string. So we're gonna stick with Rust string instead of OS string just for consistency's sake. Yep, so got end args, and we collect that to turn it into a vector. Alright. Yep, collect can just be called on any iterator to turn it into a collection. Woo! Functional programming. Yep, so debug formatter. Yeah. Yeah, that works, yay. Yep, first value is target minigrep, which is the name of our binary. This matches the behavior of the arguments list in C, letting programs use the name by which they are invoked in their execution. Often convenient to have access to the program name in case you want to print it in messages or change behavior of the program based on what command line alias was used to invoke it. But for the purposes, we'll just ignore it and only save the 2 arguments we need. So, let query equals and args1. Let file name equals and args2. And we can print searching for badum in badum. I'll just put it on one line. Query file name. Alright. Now, there's a panic risk here. If you run it without those being there, boop, panic! Oh no. Alright, so temporarily print these values, yep, and values the arguments we needed are being saved. We'll add error handling later to deal with no args or whatever. I would, yeah, if there is like a way for is there like a, launch config stuff, okay, yeah. I'll like look into that at some point, but yeah, launch config, yeah, oh, no debug target. Okay, don't care, yeah. But yeah. We can figure that out later. I would really, but like having some way to like say, hey, Rust Analyzer, use these args when running. That'd be nice. We'll add some error handling to deal with certain potential running situations. Yep. Alright, file reading. Alright, let's just, alright, so poem txt, and I'm just gonna copy paste, paste, save, just cause it's not super critical, not code, so I don't need to like write it down to remember how it works. Okay, so yeah, then we're gonna use standard file system. Yep. Alright. Yep. So let contents equals file system read to string file name dot expect something went wrong reading the file. I wish it was like more forgiving with like when it would actually, like, I wish it would like always like auto close those instead of like duplicating them. Yeah, then println file has contents backend contents. All right. Alright. Another temporary println. So, nope, there. New terminal. Cargo, run the poem txt. Alright, yay. Woo, that works. Alright, awesome. Takes up hell of a lot of screen space, so I'll just shrink it for now, but yeah. Code's read then printed contents of the file. Code has a few flaws. Has multiple responsibilities. Generally, functions are clearer and easier to maintain if each function is responsible for only one idea. Other problem is that we're not handling errors as well as we could. The program is still small, so these flaws aren't a big problem, but as the program grows, it'll be harder to fix them cleanly. It's good practice to begin refactoring early on when developing a program, because it's much easier to refactor smaller amounts of code. We'll do that next, yeah. I remember someone in like one of my discords mentioned recently. Let me see. That one. Yeah. The TLDR of it is just like if you the more functions you split something up to in a compiled language, the better, because during optimization passes, it will just like end up inlining functions if it can. So like, the smaller it is, the more situations it's easy to inline in. Alright. Our main function now performs two tasks: passes arguments and reads files. Isn't a major problem for a small function, but if we continue to grow inside main, it'll become a god function, and that's not good. Yep. More difficult to reason about, harder to test, and harder to change without breaking one of its parts. Best to separate functionality, alright. Dives into the second problem. Although query and file name are configuration variables to our program, variables like contents are used to perform the program's logic. The longer main becomes, the more variables we'll need to bring into scope. More variables we have in scope, harder it'll be to keep track of the purpose of each. Best to group the config variables into one structure to make their purpose clear. Third problem is we've used expect to print an error message, but the error message just prints something went wrong reading the file, so we can like just deal with that in a bit. But yeah, regardless of the situation, yep. Fourth, we use expect repeatedly to handle different errors. Yeah. Do we? Yeah. Yeah, user runs our program without specifying enough arguments, they'll get an IOB, yep. Clearly doesn't explain the, yeah, that doesn't clearly explain it, yeah. Oh yeah, that is, get expect, effectively. Yeah. Alright. Be best if all the error handling code were in one place. So, separation of concerns for binary projects. Let's make a librs. Alright. And yep. Process the following steps. So, split into main RS, librs. As long as your command line parsing logic is small, it can remain in main RS. Then, when the command line parsing logic starts getting complicated, extract and move to lib. Okay. Responsibilities that remain in main are calling command line parsing logic with arg values, setting up any other config, calling run from librs, and handling error. Run returns an error. Okay. This pattern is about separating concerns. Main RS handles running the program, and librs handles all the logic of the task at hand. Because you can't test the main function directly, this structure lets you test all your program's logic by moving it into functions in librs. The only code that remains in main RS will be small enough to verify its correctness by reading it. Woo! Alright. Let's get going. So, yep, alright, time to start doing things. So we'll then parse config args and string. That's an array slice, okay. 2 and stir let query equals and args1 let file name equals and args2 return query file name. You know what? I'm gonna start going with like the Rust convention of like just having like the return of having like implicit return like that. But yeah, gonna get rid of that. So we're gonna instead have let up query file name equals parse config and args. Alright. Yeah, that separates them out. We'll probably want to switch that to get and such, but yeah. Alright. Yeah. Alright, parse config function then holds the logic which determines which argument goes in which variable and passes back to main. Yay! Still create query and file name variables, but the actual function is bound over here. Yep. May seem like overkill, but we're refactoring in small incremental steps, and we're gonna get bigger, faster. We've got to handle like errors and everything too, so like having that there is better. After making this change, run the program again. Yep. Yep, searching for the and poem.txt. Yep, looks good. Alright. Grouping config values. Okay, so we can take another small step to improve. At the moment, we're returning a tuple, but then we immediately break that tuple into individual parts. This time perhaps we don't have the right abstraction yet. Okay. Yep. Another indicator that shows there's room for improvement is the config part of parse config, which implies two values return are related and both part of one configuration value. Yep. We're not currently conveying this meaning in the structure of the data other than by grouping the two values into a tuple. We could put the two values into one struct, then give each of the struct fields a meaningful name. Doing so will make it easier for future maintainers of the code to understand how the different values relate to the each other and what their purpose is. Hooray! Anti-patterns! Yeah. Alright. Yeah. Now that we know about that, because there's like low-cost abstraction in Rust, we don't have to like worry about using too many primitives, we don't have to worry about like using too many like structs or such. Hooray, ZCA! Alright, Alright, so we're gonna make instead a struct config query string file name string, and we're gonna clone them now. Okay, so config, yep, makes sense because like we don't want to have to deal with lifetimes. Yeah. Dot clone and dot clone, then config query file name. Alright. Then that can just be config and config dot config dot config dot Okay. Oh, don't borrow. We're stealing them. Or we're cloning them, but yeah. Okay. Ah. Dropped one my... Ah! No, 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 no. Go back, go back, go back. Ah, thank you. Ah. Bumped the wrong keys. Wee. Yep. Alright, signature parse config now indicates it returns a config value. Yay. The body of parse configuration returns string slices. Now define config owns with own strings. Alright. Args variable in main is the owner of the argument values and is only letting the parse config function borrow them. Yep. Huh. So, yep. Which we'd be violating rough bar rules if we tried to take owner of the values in arg, so we can just clone them. Make a full copy of the data. Takes more time in memory than storing a reference. However, it also makes our code very straightforward because we don't have to manage the lifetimes of the references. In this circumstance, giving up a little performance to gain simplicity is a worthwhile trade-off. Yep. In Chapter 13, you'll learn how to use more efficient methods in this type of situation, okay? It's okay to copy a few strings and continue making progress. Got it. Ah. Alright. Yep. Ah, for now it's okay to copy a few strings, yep. File names in query string are very small. Better to have working program that's a bit inefficient than try to hyper-optimize on your first pass, yep. It'll be easier to start with the most efficient solution as you become more experienced, but just start simple. Get fancier later. Okay. Got it. Yeah. Alright. Okay. Updated main so it places the instance config returned by parse config into a variable. Updated code that previously used separate query and file name variables, so now uses the fields instead. Yep. Now our code more clearly conveys that query and file name are related and their purpose is to configure how the program will work. Any code that uses these values knows to find them in config. Watching my... Huh. Right, creating a constructor. Okay. So far it's extracted logic, but yep, so yeah, it shows we can show the related, yep, and conveyed in code. Added config to name the related purpose, then return the, yep, them out from parse config. Alright. So, why not, instead of having a separate function for creating it, we just make an associated constructor. Impl config a new args and string to config, and it's just this code pretty much. Then config new. Woo! Okay. Updated main, yep. Don't need anything else, yep. Error handling time, okay, because right now it'll just panic if I hit that run button up there. Yeah, prove the error message, so in new we can if args len less than 3 panic not enough arguments requires at least 2. Yeah, not enough arguments. And semicolon. So if I click run here, Not enough arguments, yep. Got it, yay. Alright. Similar to guess new function we wrote in listing 910, yep. We're called panic when value argument was out of range. Instead of checking for range values, we're checking the length of args is at least 3 and the rest of the function can operate under the assumption that this condition has been met. If args has fewer than 3 items, this condition will be true, and we call the panic macro to end the program immediately. Now you might want to do a bit more graceful handling, just because that'll give like a lot of extra data that we don't necessarily want, but yeah. So run the program without any arguments, yep. Instead of saying thread main panic, you would probably want to make a, yep, extraneous information we don't want to give to our users, yep. Yeah, we can use other technique, return a result. Okay. So now we're gonna do result config and stir. Then we can, okay. Then we can return error. Alright. New function now returns result with config. Yep. Made 2 changes in the body in the new function instead of calling panic when the user doesn't pass enough arguments. Now here's what we can do here. But question mark. Yeah? Is that illegal? Alright, yeah, we've got a result. Wait, no, you can only return an I32 there, so yeah, question mark won't apply. But that's still legal, so we've got to do something about it. Alright. Unconfig, yep, so. Yeah, what we can do instead is closure time, unwrap, or else, bar, error, bar, open curly bracket, okay, println, problem, parsing arguments, error, process, exit 1. Alright, I like that. I like that syntax for a lambda. That's pretty alright syntax for a lambda, yeah. Okay. Why are you angry? Why are you angry? Huh? I'm using unwrap or else, yeah? Fun wants E. Expected config got. Yeah, why? Why is... Why is? Like... Why is it getting unit? Like... Oh, config stir. Unwrap or else. Nope, wrong key. Unwrap or else, yeah, takes self op F, which is fun once E, and to T, and I don't get it. This is What's the type of config? Config is just here. It's just a struct. Like, pretty basic struct. Yeah, and like that's being passed through a result config and stir. What? I'm gonna... Yeah, that is identical. Why? Oh, I forgot to... Why isn't it saying that there? Oh, it's because I forgot standard process. I don't get why... I guess there's some... Yep, don't have process imported. Yep, I did not, but for some reason Rust Analyzer was not actually properly analyzing the lambda. So, like, the Rust compiler did it perfectly. I just guess there's just... It should just import that. Yeah, I think it was just a weirdness with, like, the lambda being invalid, so it was not properly, like, understanding the expression, but come on, just... Rust Analyzer was just bugged. Okay. That is weird, but oh well, yep. Yep, past the inner value of the error, yep. Alright. Not enough arguments, yep. Add a new use line to bring process from the standard lib into scope, yep. Run in error case only 2 lines, then call process exit, yep. So like if we cargo run now... No, not up there. Yep. Problem parsing arguments, not enough arguments, yay! Much friendlier, woo! Now, let's get this out of main. Alright, so, now I've finished refactoring the configuration parsing, let's, alright, start splitting, so, let's have a fun, and run config, then we can just copy this, This will take ownership of it, which is fine because we don't need it here, so run config. Alright. Run function now contains all of the remaining logic from main, starting from reading the file, okay. Yep. Run takes config instance as an argument. So we can now return errors from run if we want, so... Oh boy, box time, so return result, unit, or boxed in error. What the fuck is a box? Okay, oh, it's just a pointer type for heap alloc. Okay, yay! Wee! Okay. Smart pointer, okay. I'm going to pretend I know what the fuck a smart pointer is, but... Then we can just... Okay... Pass the unit back. Result. Oh, yeah. Use standard error... Error. Yep. Then we can do like stuff there, okay, yeah. We've made 3 significant changes here. First, we changed the return type of run to result boxed in error. This function previously returned unit type only and keep that value as returned in OK. For the error type, we use the trait object boxed in error, and we've brought standard error into scope. Use, okay. We'll cover trait objects, okay, so that's what trait object looks like, okay. Boxed in error means the function will return a type that implements error trait, but we don't have to specify what particular type the return value will be, okay. Alright, so that's just dynamic programming. Okay, got it. Fun. Sure. Alright. Alright, removed call to expect in favor of the question mark argument. Yep, Pep. 9 o'clock, okay, yeah. Keep going for a little while longer, yeah. Think it's dynamic dispatch, yeah. Trait objects, yeah, that's like OO stuff. Don't have to specify what particular type the return value will be, okay. Yep, remove expect just a question mark. Alright, it'll return the error value. Alright, run now returns an OK in success. Play the run function, success type as unit. Means we need to wrap the unit type, okay. Yep, might look a bit strange, but this is the idiomatic way to indicate we're calling run for its side effects only. Whee! I love calling something for its side effects and for nothing else. Alright, when you run this code, it'll compile but display a warning because I'm not doing anything with it. Just returned result and might indicate error. Yep. Alright. Error handling. Alright. So we're gonna do if let, so if let error e equals I still don't like this syntax, but it's from other languages, so I guess I just have to accept that it's kind of standardized. Println application error E then process exit 1. Alright. Yay. If we use if let rather than unwrap or else to check whether run returns an error and call process exit 1. Run doesn't return a value that we want to unwrap in the same way that config new returns config. This run returns unit. In the success case, we only care about detecting an error, so we don't need unwrap or else. Because, yeah, we don't care about the unwrap value. Fun fact, as of recent Rust versions, you can just, yep. Oh, Maddie Makes Games, hello, hello! Fun fact, as of recent Rust versions, you can just do println to print a variable. Yeah, I've seen that around. But, yeah, so I can just do E. So yeah. No argument named E. Might not be on. That might still be nightly, but yeah. That is cool, and I'm excited for that. That's helpful. Oh, alright. And now, yep. Now we just print the error and exit. Okay. Yeah, that is a very cool one. Yeah, that's a cool upcoming thing. So yeah. Alright. Time to start throwing shit into librs. Okay. Alright, so yay. then use mini grep. Oh wait, no, process stays there, okay. Then... Alright, I'll take care, I'll be going off now. See ya, Rem! Yeah, maybe that's just where I had before, yeah. Hope the coding goes well, thank you. Alright, I haven't put it into a module yet, whoops. Or, you know, I've gotta, pub them. Pub. And, pub. And, pub. Yeah. We don't want to run down at the bottom, okay? Illegal? Alright, yeah, forgot to put the pub. And pub. I don't... What do I... Oh, I keep accidentally bumping Command W. Whoops. Or Control W, yeah. Should be stable as of 158 select... Oh, Rust up? Where did I just... Rust up update. Alright, come on. Alright, installing new Rust, new Rust C, okay. Only 65 megabytes for Rust C, huh? Alright, Rust up! So now I can E and there. Now that's legal, yeah? Yeah! Cargo run the omtxt. Yay! Now it's legal, woo! I've slowly been converting all my old code to use new capturing format strings, yeah. That, look, I've just gotta say, that was the most painless update for a programming language I've ever used. Like, that was the most painless update I've ever had. Thank God. Alright. Like, what the fuck? I didn't even need, like, sudo for it? Which, minorly worrying, but oh well. Okay. Yep. Just throw pub everywhere we can, yeah. Good string interpolation is very nice to have, yeah. Okay, ears congested, yeah. Where am I right now? Fuck it, I'll keep going until I'm done with this project, yeah. I can go longer, but yeah. Java's, plus good enough for that, I've regularly been switching back and forth between stable and nightly for a while, been pretty painless, yeah. Is the template syntax better? I think template syntax is a bit better just because, Java's, template syntax actually lets you do, like, some, like, fancy formatting. So you can, like, choose to, like, represent something in hex or octal or such. Yeah, Java, main problem is that can lead to some nasty perf concerns, yeah. Yeah, performance with string interpolation is a bit rough sometimes, but yeah. Yeah. That's a lot of work, but we set ourselves up for success in the future, yay. take the advantage of this newfound modularity by doing something that would have been difficult with the old code, but it's easy with the new code. Testing time! Yeah, since string interpolation tends to allocate a lot, yeah. Hopefully Rust is cheaper. Let me actually see, yeah, still waiting for us to get full expressions and format strings, then they'll be perfect, yeah. That'll be interesting, but yeah, And he said string interpolation, I think going for I and ABC to ZZ, yeah. And stringification in general can be pretty expensive, yeah. Okay, so, test-driven development, woo! Test-driven development sucks in most languages because tests suck in most languages. String interpolation is the variable stuff, yeah. Yeah. C# has it and calls the feature that, yeah. Okay, so let's do TDD, okay. Process for test-driven development is write a test that fails and run it to make sure it fails for the reason you expect. Write or modify just enough code to make the new test pass. Refactor the code you just added or changed to make sure the tests continue to pass. Continue, repeat. How's it interpolation? It's just there's probably like some fancier like reason why, but like that's just kind of what folks have started calling it. Let me string interpolation. Yep, yeah. Oh, it's because it's logical, yeah. Alright, string interpolation allows easier and more intuitive string formatting, yep. Yep, quasi-quotation, yeah. Yeah, I'm not sure specifically why it's called that, but yeah, yeah. There's replace and expand and split and join. Security issues, wee! Never the meaning, but okay, yeah. Not sure why it's called that. It's, why is it called string interpolation? I don't see anyone actually, like, really properly explaining it, but yeah. Oh yeah, interpolation in general, just inserting data into something else, but yeah. Yeah. Alright, but yeah. Linear interpolation is literally creating new data, yep. Just new data based on, formula. That formula being just, yeah, just like a linear path, but yeah. Alright. So, TDD time, okay. So, over in librs, we'll just, alright, hash cfg test mod tests use super hash test and one result let query equals duct let contents equal Rust. Ooh. Is that how you do a multi-line string in Rust? That's interesting, okay. Safe, fast, productive, pick 3. Is that how you do multi-line string in Rust? Because that's an interesting multi-line string syntax. Okay. Alright then. Assert ec safe, fast, productive, search, query, contents. Typically use R hash, but yeah, only if I don't care about indentation in the string, yeah. Yeah, raw string is like a good one too, but yeah. There's more you can do. I think the backslash is to skip the new line, yeah. Or, wait, are Rust strings just natively multi-line? Huh. Yep. Only, yeah, search through the string duct. Text searching is 3 lines, only one of which contains duct. No, backslash at the, oh. Ah. Alright, so... I also don't use multi-line strings often yet. Strings are inherently multi-line? Okay, yeah, that's neat. Sure, yeah. I'm up for that, yes. The inherently multi-line strings? Cool. Now, search currently doesn't exist. Alright. Okay, so... Song, please. Alright, so now we're gonna make our hub fun search prime A. Alright, so that means we're setting a lifetime, alright, to the lifetime of the contents. Got it. Query and stir contents m prime A stir to vec and prime A stir. Alright. Then we can just vec, but and just do that for now, okay. Now, if I run this test failed, yay. Alright. Okay, so that failed, got it. Most of the time I do it's inside of a macro, yeah. Alright. Call in chapter 10, lifetime parameters specify which argument lifetime is connected to the lifetime of the return value. In this case, we indicate that the return vector should contain string slices that reference slices of the argument contents rather than an argument query, okay. In other words, we tell Rust that data returned by the search function will live as long as the data passed into the search function by contents. Yep. This is important. Data referenced by a slice needs to be valid for the reference to be valid. If the compiler assumes we're making string slices a query rather than contents, it'll do its safety checking incorrectly. And it'll just, like, be upset. Yep. Yep. Function's return type contains a borrowed value, but doesn't say whether it's borrowed from query or contents. Consider introducing a named lifetime. I think that's cool. Yeah. I like how helpful the errors are. Like, a program telling you what is wrong is good. Rust can't possibly know which of the two arguments we need, so we need to tell it. Contents the argument that contains the text, we want to grab it from, yep, we want to grab the lifetime from there, okay. Makes sense, yeah. Other programming languages don't require you to connect arguments to return values in the signature. Although this might seem strange, it will get easier over time, yeah. Like, it completely makes sense. If you're returning, like, a borrowed value like that, then it's gotta be, like, thinking of it as borrowed means, like, it has to be borrowed from something, so just, you're marking the thing it's borrowed from. Alright? Yeah. Yep, and that will fail. Yep. Yeah, the tests will fail just because they're supposed to, yeah. Coming from mainly a JS background, lifetimes took me so long to fully internalize, yeah. Like, ultimately what like, I, like, at least know, like, a bit of, like, the lower level stuff. Like, I know theoretically, or, like, I know on a theoretical level, like, how a computer works. So, like, just the rules of, like, how this interacts with how a computer works is, like, helping me, like, understand it a bit better. Yeah, Maddie, you coming from a JS background actually really, once again reinforces something that, like, someone I saw on Twitter, like, mentioned a while back, is that, like, most of the folks, like, experimenting with Rust aren't, like, C or C++ devs wanting to make programs safer. They're JavaScript or TypeScript devs wanting to make programs faster, which I think is really interesting to just notice as, like, it's an unintended use, but, like, given that, like, Rust is entirely, like, WASM ready, like, I think that's, like, a big thing to note, and it's really interesting. Alright, now, it's time to write code to pass the test. Alright. Currently, our test is failing because we always return... I mean, Rust was made by Mozilla, yeah, exactly. Originally, yes, yeah. Yeah, before Mozilla decided it wanted, or before Mozilla decided it didn't want to be a, productive force anymore. Yeah. Back to the traps to web dev is pretty natural, yeah. Started learning Rust because I thought it looked nice and because it was faster, yeah. Rust is a really interesting language, like, I think, like, even if, like, Rust itself as a language doesn't stick around, which I think ultimately it will at least have a big impact on, like, people's thoughts about, like, friendliness of a programming language, of, like, of a compiler, of, like, of documentation. Like, that friendliness is really, really important. I want to make things that are as friendly as Rust. Yeah. Currently our test failing because we just always return an empty vec, so it can't do it, but yeah. So, to fix that and implement search, our program needs to follow these steps. Iterate through each line of the contents. Check whether our line contains our query, whether the line contains our query string. If it does, add it to the list of values we're returning. If it doesn't, do nothing. And return the list of results that match. Alright. Let's work through each step, starting with iterating through lines. Alright, yeah. So, we're gonna just start with for line in contents lines. Alright. Yay. Iteration. Yeah, hooray for, like, a built-in lines thing. Then, like, if line contains query. I think the biggest plus of Rust is how it's so easily pluggable into a C++ codebase, because, like, I can just add C libraries as dependencies. Yeah. Like, there's, like, like, the fact that, like, like, I think that's, like, the killer thing with Rust is that, like, so many times when you, like, have a new programming language built on, like, to interop with other existing stuff, like, it's just really messy. Like, there's, like, there's weird stuff that can happen when you try to, interop, like, Java and Kotlin or such. C++ is not the easiest to interop with, but yeah. Not direct. Quite a few languages have good interop with C, yeah, like, C is basically the standard to interop with, and the fact that Rust can just do it is really good. Yeah, like, having that, like, good interop there is pretty crucial. Yeah, like, bind gen is one of the best things that Rust has. That reminds me, Golang can as well, C# can with a little work on the marshalling side, yeah. Yeah, just, like, with a little work is a problem. Like, it should be, like, optimally it should be 0 work, even though that's very difficult, but yeah. Who was it doing that again? Not Ella's. Was it? Yes, actually. Yeah, I'm remembering a really interesting, really interesting graphics library from a little while back, by former Minecraft modder Ellicent. It's called LibDraw. It is like a shallow OpenGL wrapper with fixed function interface designed for C++, and, they have talked on Twitter about, like, making it just, like, as simple an ABI as possible. Like, you're never using, like, pretty much all the arguments ever, all the arguments it uses are, like, just either it's, supplied structs, or it's, or, like, primitives, which is neat. Yeah. I have part of my Python library that does some C interop, and G's Python interop with C is really annoying, yeah. Can you pass C++ stuff through the C ABI to Rust? Yeah. I believe, yeah, I'm pretty sure you can, and, like, especially with, like, something designed for easy ABIs like this, it shouldn't be that hard. Very rarely work with C++, yeah. Yeah, it really depends on, like, yeah, you need to make it a C-type. Yeah, that is, like, the main challenge with, like, C++ and ABI is just, like, C-types, but yeah. Yeah, I've been, like, learning a bit of C. It is really something. Yeah, Non has recommended some interesting stuff to me, which I should, nope. Yeah, which I really should check out at some point, stuff with Unity builds and such. By the way, yeah, Ellison does some, like, cool stuff. Yeah, quote, yeah, like, there was another thing I looked at recently, which I'm very interested in. Basil is, yeah, oh, archive only, huh? Alright. Oh, because it moved over here, yeah. Basil is an interesting language, which I've been meaning to look at. It is it's generally Lispy, and it pretty much has, yeah, like, no keywords, almost no rigid syntax, even primitive types and operations can be extended, yeah. Like, it is a very interesting thing, yeah. Manipulation of syntax, yeah. I am very interested in, like, giving Basil a try sometime, just, like, as an experiment. It looks really, really interesting. Yeah. Yep. The whole compiler and runtime is under a megabyte and is just libc, which, that's really interesting, yeah. Only seen that in Haskell operators, yeah. Yeah, partial eval, yeah. Very interesting stuff going on here. I'd love to give this a check out. Yeah, give this a look. Yeah, they're planning for, like, x86, AR64, RISC-V, LVM, WASM, so yeah. Yeah, should be cool. Very excited for it. Definitely gonna give it a look at some point. Yeah. That is gonna be, like, an interesting language to look at, because it's basically designed for making your own DSL in. Much as John Blow's an ass, I must admit I'm still interested in his programming language as well. Yeah, fuck John Blow, but, like, yeah, but, like, fuck John Blow. Piece of shit. But he can code, and I am interested in stealing permissive license things from jerks. Yeah. Yeah, if line contains query, now we can... Alright, so now we'll want, let mute results. equals vec new. And that's vec unknown, so we can results push line, then we can just results at the end. Okay. So now, if we run this test, woo, test passed, hooray! Yep, one result okay. Fuck yeah. Alright. Yay, that's a test. We know it works. At this point, we should consider opportunities for refactoring the impl of the search function while keeping the test passing to maintain the same functionality. Code in search function isn't too bad, but it doesn't take advantage of some of the useful features of iterators. Return to this example in chapter 13 where we'll explore iterators in detail. Yeah, yeah, basically it's just, they're just gonna do mapping and such, I'm guessing. Or yeah, that would be, content, lines, filter, line contains, query. Yeah, I'm just gonna check this out. Oh no, paren. Oh, then collect. Should be enough, yeah? Oh wait, no semicolon. Then run the test. Woo! Oh, okay, I feel iterators are so good, yeah. Iterators are one of the cooler parts of, yeah. Yeah, like, iterators and functional programming are really interesting. I'm so fucking glad that, like, Rust is just, yeah, is not, like, being super, like, that's another thing I like about Rust, is they've actually made, like, functional programming accessible. Like, I don't know how to emphasize that, like, describing functional programming exclusively in mathematical terms is a hell of a barrier to entry. And, like, having things that, like, describe, describe functional programming without, like, actually, like, oh, yo, Nikki, hello, good to see all of y'all, yeah, ooh, Maddie Makes Games, thank you very much for the follow, welcome to Uplink City, yeah, for all of y'all joining in for the first time, hello, I'm Lemma, I'm a chubby queer robot VTuber who both makes and plays games on stream. Tonight I'm learning how to use Rust, I'm talking about programming languages, I'm having a good time, yeah, As I was saying, like, right when you got in, I am so glad that, like, Rust teaches you how to do functional programming without any of the mathematical terms. Like, you can go for a really, really long time in Rust without learning that, let's say, for example, result, without knowing that, like, result is a monad. That's, like, the fact that you don't need to learn that to be able to understand Rust is a really good thing. I should put this in lib. But yeah, like, you see, yeah, like, result or option or vec or such, those are monads. But yeah, seen similar features, but that's it, yeah. No idea what a monad is, and at that point I'm afraid to ask, yeah, let me summarize in a bit. Yeah, how are you doing? I'm doing really good, yeah. I've been programming for a very long time, and I still don't really know what a monad is. Basically, there are, two parts to a monad. A monad consists of two things. A box, and, contents, lines, there are two things that a monad is. it is a box, and it is this method, flat map. Yeah, if I, like, hit F12, yes, this, yeah, so this function signature here, flat map u of f, yeah, yeah, like, that is basically what a, yeah, like, a flat map is basically just that, signature of, like, a function that takes in, the type, or that takes in the type, performs something on it, and then returns the wrapped type, even if it's, like, a different internal type, yeah. Let me actually, there's some weird stuff going on in there. Let me actually try and, like, write it out, so, let's say we have, yeah, alright, oh, that's actually a good one. Let's say you've got a list of strings. So, you've got a list of, string slices. Let's say that you want to, convert them into, like, own strings. Or, like, make own strings from them. Let strings equals, yeah, so, like, we're getting that, so, like, contents.lines is giving us, like, just, lines, which is a type over just, like, a map, which is ultimately just which is just a vec of string slices, ultimately. So, taking from that, like, we have a vec, so, like, let slices, which is vec and stir equals contents lines. Yeah, so this is effectively what, like, contents lines is. It's a vec of string, but let's say we want that to be let strings, we want it to be a vec of proper strings. What we can do is slices flat map, into iter, just because that's how it does. Then flat map, yeah, that will be slice, yeah, so that will be slice, then string from slice dot collect. That is basically what monad is. Don't see why you're flat mapping instead of mapping. Just because the flat map is, a flat map is the operation that actually defines a monad, not map, interestingly. But yeah, basically, what a monad means is that if you have, it's a wrapper type where you can call operations on it that can transform the inner type while keeping the outer wrapper. So, like, options, like option with then in Rust is a monad. Vec operations or anything with an iter is a monad, stuff like that. All it means is that you've got stuff, you've got a wrapper that transform, or, words, brain scrambled, A monad is a wrapper that you can perform operations on. That flat map was like, nope. Yeah, it is map is a different type signature. Yeah, anyway, yeah, like, the fact that you can, like, use, like, that, like, chaining without knowing what a monad is in, like, Rust is a good thing, because it means you don't need to have, like, a level of, like, academic theory experience. Yeah, yeah, like, I think functional programming is really good, it's just never explained well. Like, you shouldn't have to know, like, you shouldn't have to know type theory or, yeah, at an academic level to do functional programming. Yeah. Okay, so use the search function. Oh, actually, oh, shit, did I ever get you a shout-out, Nikki? I did not see, Yes, we did. Oh yeah, you were playing Legends Arceus. How was that? Hope it's been fun. Yeah, I got it, yeah. Alright, yeah. How is Legends? I've heard a lot of good things about it so far, and I cannot wait. Yeah, I cannot wait for my copy to get here in a few days. Yeah, yeah, I'm really happy with this, like, compressing that into, like, one function. Flat map will let you take an option insert and convert it into an option and, oh, in the closure back to option insert the return. Yeah. It might be math? Yeah, like, just the ability to perform operations on the underlying data while still keeping it in a wrapper is what a monad is. Yeah. So, like, doing things to an array, yeah, like, with, like, doing like, mapping things, yep, iter, map, flatten, yeah. Yeah, I've pulled this up multiple times. Monad functional programming. Is it map or flat map? Yeah. Yeah, I might be switching them up, but yeah, yep, yeah, yeah, so, yep. Yeah, it is, yeah, I think there's just a lot of academic language around it, which is annoying. But yeah. Basically, you've just got, like, a wrapper that you can affect the data on while still inside the wrapper. So, like, option and then. Yeah. Yeah, so, like, option and then in Rust, or, like, mapping on strings, or, like, list comprehensions in Python. That is, like, yeah, like, if you're doing list comprehensions to convert the type of one list into another, that's a monad. Flat map is fx to x, fy to fy, yeah. Yeah, yeah, like, I think, like, the two things that, like, aren't explained well enough in, yeah. I think, like, the two things that are not explained well enough in functional programming are, one, what monads are, and two, what currying is. Yeah, like, just, I do know what they are now, yeah. Like, user optionals, yeah, like, I wish I had, like, better, I should probably write up, like, a proper, like, layman's explanation for, like, monads and currying sometime, instead of, like, just trying to bring up the words while I am on Adderall and thoughts are, like, running, like, 5 times faster than my mouth can move. But yeah, Sounds good, yeah. Alright, so now that we've confirmed that our search function works, and I'm very proud of, like, converting it into, like, one function. Literally know nothing academically about functional programming. I've been using Rust for almost 3 years or something, yeah. Yeah, like, functional programming is cool, and you should not need to know about it academically to be able to use it. Yeah. Alright, so now that we've got this, inside of run, instead of just printing that out, we can for-line in search and config query and contents println line okay. Yeah, now if I search cargo, if I do cargo run frog, let me pull this up. Boom. Alright, yay! Found one! Then also for body. Woo! Then don't get any lines for something, yeah, that isn't in there, so morphization. Woo! Works! I did learn you a Haskell before reading the rest book, yeah. I should look into learn you a Haskell, yeah. Alright, yay! Alright. Yeah, we've built our own mini version of grep, yep. It doesn't do like proper regex, but yeah, that's hard. Never really done pure functional programming, though in my experience when you write programs, well, the code ends up pretty functional in practice, yeah. Is that a pun? Yeah, no. I'm not sure if it is, but yeah. Yeah, like, there's like a really interesting, like, pattern that, like, Gary Bernhardt talked about in one of his talks, Boundaries, which I highly recommend. It is, like, kind of a fusion between object-oriented and, functional programming where you, don't have mutation, but you do, like, but you do keep data and code combined, which is kind of really what Rust is geared for. What are you finding most difficult about Rust Lifetime so far? Yeah. Hello, Stovoid. I'm actually not having too much of a hard time with Rust Lifetimes if I, like, stop to think about them. Like, that's the thing about, yeah, like, that's the thing about Lifetimes is that they are very much a sit down and think about what you're doing problem. And if there was like a layer on, if there was like a visualization layer for like lifetimes of borrows, inside of like, yeah, inside of like Rust Analyzer such, I think that'd like basically be a solved problem, yeah. Lifetimes only get hard when you're dealing with passing lifetimes around inside a structure through multiple functions, yeah. Yeah, like, I've got my head, like, pretty well wrapped around, like, lifetimes and how they work, so yeah. Like, I just need to, like, get more experience of using them in practice. Just gets hard to find where the data is borrowed from, yeah. And, like, I think that is very much a thing that, like, good tooling, good IDEs, and, like, analysis stuff can, like, help deal with. Yeah, like, it's like having having an IDE that can, like, trace, like, your lifetimes and such would be a very good thing. Yeah. We'll improve minigrep by adding an extra feature, an option for case-insensitive searching that the user can turn on via an environment variable. Whee! Could make this feature a command line option and require that users enter it each time they want to apply, but instead we'll use an envar. Doing so allows our user to set the envar once and have all their searches be case-insensitive in that terminal session. Only got in trouble with lifetimes when trying to do something I shouldn't, yeah. Yeah, like, just, that's, like, the big thing with lifetimes is, like, one of the best solutions for, like, a lifetime problem is to just rewrite your code in a different way. Yeah. Alright, so, we want to add new search case insensitive function that will call when the environment variable is on. We'll continue to follow the TDD process, so, time to write a failing test. Alright, so the hash test, or no, hash test, yeah. Hash test. Then case sensitive, yeah, then this will be, right, so this one will be case sensitive now, then we've got a case insensitive one here. Let query equals RUST. Let contents equals, I can just copy this, right? Assert ec. Alright. Up. Spec. Rust. Up. Colon. Then trust me. Up, comma. Yeah, this is what I don't like about RustTB. It's often the solution to an error is to completely restructure your code, which can be real frustrating, yeah. Search case insensitive query contents. Yeah, like, I do think, like, yeah, I think there should be, like, better solutions in a lot of cases than restructuring. Fell in love with Rust for years, used it for every neat project I had. Now I think I found myself moving back towards the stack high-performance GC languages because it turns out it's easier not to worry about ownership. It's almost like a new programming puzzle that only Rust includes. Yeah, it is definitely a puzzle, and I think, like, there are advantages to, like, yeah, I think, yeah, having to, like, rewrite code in, like, in order to fix, like, lifetime problems can be, is annoying, but, like, I do think there is also a bit of merit to it because it encourages writing, like, cleaner code. A few times I got hit for mutating a borrowed value during a loop. Usually replace the loop var with an index, but later I realized I could kill the borrow early by assigning something else, doing the thing, and then borrowing it again. Yeah. You know, like, languages should be designed to help you write good code. Love Rust, don't get me wrong, but man, it's a hassle. I'll pull it out from my real-time hardware projects, though, yeah. Don't think the code is necessarily cleaner, though, just more idiomatic. Yeah, that's fair. Yeah, like, Rust I can definitely see for, like, using in higher performance scenarios, but, like, I am very familiar with, yeah, I'm pretty familiar with Python. I am way too familiar with with Java, even though I will maintain the JVM is one of the most magnificent pieces of software ever made. Yeah, so now this test will fail because it can't even compile, so pub fun search prime A, or no, this should be case insensitive prime A query and stir contents at and prime A stir to vec and prime A stir vec there. So now that this will fail. Yep. Alright, so that fails, yeah. Modern C# is pretty amazing too, yeah. C# better than Java, yeah. Yeah, I have Rust I think is generally cleaner until you get to the crazy generics and macros. That's also plus Rust too, yeah. Like, macros are nice. Do find myself missing those in other languages. Go's code gen solution to compile time logic is yuck, yeah. Yeah, I have been meaning to, like, learn C# a lot, especially with, like, Hypercosm and, like, Sarah's doing, like, netlib in C#, so I'd probably want to use that, but yeah. I should do some, like, Hypercosm dev at some point. Like, on stream. That'd be very interesting. It's kind of gotta wait till things are set up enough, but yeah. Then learning C# just because of Unity, it's nice though, yeah. Rust macros are the best part of laying them out. Proc macros just make things so nice to work with, yeah. Yeah. Rust macros are good, yeah. Alright, so yeah, now we've got, yeah, a failing test, which means we can write code that works for it. Yeah. Now we can basically do the same thing. Yeah, let query equals query to lowercase. Then, yeah, that'll just shadow it. Right, then I can just do the same thing effectively. So contents, lines, filter, line, please get out of the way, yeah. Line to lowercase contains and query. Oh, there. Ah. Alright, yeah, then collect. Illegal? Good. Alright. Yep. Alright, we'll see you around. Let me see you, see you, Stoveboy. Use C macros for generic collection types once. Had to include C files, yeah. Oh, Stoveboy, thank you very much for the follow. Welcome to Uplink City. Alright, so now if I run this test. Woo! Passed. Now I could also instead of doing to lowercase over the entire or per line, I could also to lowercase there, yeah? Oh, that returns an own string. Whoops, that's why. Alright. Yeah, I like the type hint layer and such. Yeah. Yay, that works now. Yep. Freeze now string because calling to lowercase creates new data. Yep. Alright. Yep, now let's call new. Yep. Alright, so now it's time to fuck with our struct. Hub, case, sensitive, bool. And that means it's time for more stuff, so. Alright, Alright, let results equals if config search and config query and contents else search case insensitive and config query and contents. Alright, that's an interesting ternary setup, okay. Or, yeah. That's an interesting ternary op. Now we've got to do results. That should be dot, not comma. And wait, search insensitive, yeah. Primate, sure, yeah. Alright, no, you're happy now. Okay, you just wanted to figure that out. Okay. Alright, so this won't compile yet, but yeah. Yeah, back here before 1.0 days, Rust had typical ternary operator they remove, yeah. All statements have resulting values in Rust. Yep. They will either return unit or a value, which, yeah. I'm alright with that. I am alright with that, honestly. Okay. Then, alright, in config new, okay. Then, let case sensitive. So, right, I need to, env-fs. Alright, then env var case insensitive is error, then case sensitive I just type it. Okay, yeah. Operators are less self-explanatory, yeah. Yeah, personally I'm pro more keywords and less operators, yeah, especially with Rust allowing operator overloading, yeah. Why are you angry? Oh, because I typoed it there. Whoops. Alright. So now... Alright, so... cargo run to poem txt. Ah! Alright, yeah. Because my typo. Alright, so yeah. Archery to be some. Yep, then. $env.case insensitive equals 1. Or colon, not dot. Case insensitive equals 1. Cargo run to poem txt. Alright, yay, and more. Woohoo! And I like, okay. Alright, here's the thing I like. They're using user A, yeah. A question B results in A if it is not null, otherwise B. Yeah, that is like a, no, that's a nice no coalesce. Yeah. Okay, I like this. I like how, like, they're just doing... is it just, is there a script here at all? Alright, so that's theme stuff. They're doing something here to, like, detect that I'm using PowerShell. Yeah, yeah, they're doing something to detect that I'm using Windows, so that's neat. That it, like, just... It doing what? No, yeah, like, I think that's good usability to, like, hey, like, the book detected that I am using, a Windows machine and wrote, and showed me command line stuff for PowerShell instead of, like, path export stuff. Might be via the headers? Yeah. Yeah, there are, yep, cyber JavaScript, yep, local storage, set theme, yep. I don't hide sidebar, yep. RA attributes. I mean, they do know my, yeah, like, they do know my user agent when I, like, contact the site, so. Don't remember what is it in the HTTP headers, yeah. There's user agent string, yeah, user agent includes, like, your OS, so yeah. Yeah, that's cool. Probably just using user agent. Yeah, like, it is definitely just using user agent, but that's good. That's really friendly. Holy shit. That is super friendly. Yeah. Yay! Alright, so now we have envars. And then more features, okay. And lastly, instead of just using println, we're gonna use, alright, yeah, so we can, like, pipe cargo run to output.txt, yep. So, printing errors to standard error, let's see what that is. So, in main.rs, okay. So now there's, alright, so there's EPRINTLN, okay. And I'm guessing that's it? So, cargo run to output txt. Yeah, that just works. Okay, thank you, Rust. Then cargo run to poem txt to output txt. Alright, and then that will just output txt, yeah. Yay. That's cool. I like that. That is really nice, and it's now 10:05, Jesus Christ, yeah. Yeah, this chapter recaps some of the major concepts you learned so far and covered how to perform common I/O ops in Rust. By using command line arguments, files, envars, and EPRINTLN for printing errors, you're now prepared to write command line applications! By using the concepts in previous chapters, your code will be well organized, store data effectively in the appropriate data structures, handle errors nicely, and be tested. Okay, that means next time I'm getting into the functional stuff. But yeah, God. I'm just, yeah, like, now that this is done, I am gonna switch us back over to just chatting for now. Closures, yeah, closures are nice. I like them. Yeah, God. This is such a good, like, tutorial. Like, Christ. This is, like, really good. That, like, I am just completely blown away by, like, how friendly this is. That's really, really good. Yeah, I'm just like, that's great. That is what everything should be like, TBH. Like, there should be more things that, like, are that friendly, because it's just really helpful. Now let me actually, bruh. That actually? Let me look through. It seems like it may just, like, not be doing anything. Yeah, interesting. It might not actually be doing anything with user agent stuff and might just have the PowerShell things. Interesting. Had a conflict with capturing recently, it was really annoying, yeah. Closures are really nice too, you have to care about fun versus fun mute and fun ones. Oh boy, but yeah. Yeah, Rust is a good language, yeah, especially when it says I borrowed mutably for the whole lifetime of the closure instead of during closure calls. Yeah, who should I go? Yeah, no, I am, like, really enjoying learning Rust. This is a really interesting language, and I definitely want to find something to use it for sometime. Who should I go raid? Ooh, Katan is live, and that's been going for, 6 hours, Jesus, yeah. Ended up just having to make my generic bounds close clone plus send plus sync, then clone stuff before sending it into the closure. Yeah, there's a lot of folks streaming tonight. Ooh! Yeah. Well, yeah. Yeah, ooh, someone I follow is, streaming Toontown. How about I go over to them? We're gonna... Alright, so, let me just get the phrase. So, as per usual, soft robo raid. Pass them as mutable references to closure calls. Fun. Then, alright, that's gonna be our raid phrase for the night. If you don't have the hug emote, you can unlock it for just 150 channel points. Shouldn't be a problem, because you get twice as much as that for following. But yeah, we're gonna raid Sunny Bee Flower. Thank you all so very much for watching, hanging out, joining in. Tonight's been really fun. I am really enjoying learning Rust. It's such an interesting language, and like, it's making me think a lot more about like how programming languages work, and I love that. But yeah, tomorrow I'm gonna be playing modded Minecraft on my friend's server. Gonna be fun and chill, very exciting for it. But yeah, when you get over to Sunny Bee Flowers, please don't forget to drop them a follow, because they're pretty cool. But yeah, with that, I am gonna send y'all on over. How about we get this raid started in 5, 4, 3, 2, 1. See you soon!